Hello everybody, welcome to another stream. How we doing? How's it going? Guess we'll live with that light leak in the corner. So yeah, last stream. What do we do? We got the 3D debug drawing working, so we can do access line bounding boxes, which are aligned in view space. And we can do orientate bounding boxes and vectors. And spheres as well, but these spheres aren't part of the debug drawing because these are rendered using a different renderer that we're trying to debug right now because you see it's quite glitchy. But to do that, I need the 2D ones. So we're going to add a 2D debug drawing thing. And these debug draws can be triggered from CPU and GPU code. So they're super helpful for seeing what does this variable mean. Try not to spill this Coke as I pour it everywhere. Damn it. But yeah, so, and I poured this nice can of Coke. I'm gonna go over what have we been. There's some things that happen off stream, actually. I need to touch on those. Just clear that up. So what happened off stream is I did do a couple of commits to the code base, and that is mainly I got the Windows version up and running again. So basically, the AMD driver didn't like that my on Windows. So Windows has a different AMD driver for some reason. They don't want to share code, and so they have different bugs and different drivers, which is just amazing. But if we go over to my GPU shader, here we go. So this is how I access my globals. I basically just have the global buffer as a constant integer, and I just cast that into a buffer. So in my compiler, it fetches it out of the descriptor set. Right, it's got an array of descriptors, and it just has an index. It just fetches that from. And so this was set as a read-only buffer. And so what's happening in the AMD driver is it was causing a crash because the SPIR-V that got emitted was technically invalid. We were storing into a buffer which was marked as non-writable, right, read-only. And the SPIR-V validation didn't catch it, neither did my compiler. So now my compiler just catches that. So I added a commit here, which basically does that. It says, hey, if we're making an array subscript expression and the resource access mode is read-only, add the const qualifier to the expression. So yeah, I've got some other bugs I want to sort out before I do a release of my compiler, but yeah, so I fixed that over the weekend, so the Windows build now works again, which is really nice. So I shouldn't be breaking that like I have done recently because I've been working on some foundational rendering stuff, and I think from here on out, when we get this all working proper, it's gonna be gonna have graphics all the way from here, basically, which would be good. This is so buggy. Look at that. Ugh. The tiles, screen tiles, not getting the spheres properly. No biggie. So today, what we're gonna do is start working on the 2D. Actually, we might clean up some bit on the 3D debug draw. But realistically, we're going to work on the 2D one, and then I want to probably do some debugging, actually use this debug draw and actually debug some variables for those spheres that we saw. They're just flickering all over the place. So I'll actually just be using this today and fixing a bug, and then carrying on with that in the future streams as well. So we've already done this 3D one. As I said, access line bounding box and view space. orientate bounding box, super good, and spheres and vectors. Something about my vectors though is they have a start and an end. That's when you have a vector, you don't have a start and an end. Typically, what you have is an actual vector, which is a, you know, it's a direction and a magnitude, isn't it? And so what we should really have is actually a position and then a vector that comes in as a second argument, right? And that way it will be a lot more usable in the actual sort of we actually use it in shader code, right? So we're just going to quickly amend that silliness. So this is when we write. This is the GPU code when we write it into the buffer. So we're just going to quickly just do that, and then that, and then we'll have to amend it in the CPU side code that builds the buffer, because there's a CPU and GPU version that can populate the same buffer. So that's the GPU one, then we'll do the CPU one, and then we'll edit the shader code, which basically interprets that data. So gfx.c, then at the bottom somewhere, it's here. Right, vector, position, vec, pause, vec, pause, vec. There we go. So now the rename. Oh, did I miss that? I did miss that. I don't have the language server stuff on my shader code because my compiler doesn't do that. So yeah, we picked up on the C. Oh, okay. So that just transforms it into view space from world space. Since this is the vector world space version. And then we need to then change the shader. So we search for shape type vector, and this is where it pulls it out. So that will instead be position and then vec. So now it'll be a lot more usable. So we're just going to find where that start and end is. So this is actually just wants vec, the length of vec. Pause is going to be start. This again wants to be vec. End is going to be I guess we'll pre-king. Oh no, I guess we'll just type it in here. So add pause vec. Guess so. Also, okay, well I guess we'll produce an end. Float times 3 end equal that. And it compiles. So let's say for a spin, and we should see nothing different. Oh, what's happened to my vector? That's not a good vector, is it? That vector looks off. Oh, that's because the usage code. Yeah. So cluster. Yeah, so this is so let's imagine instead that we'll go from the center position of the cluster in view space. That's where the vector starts, and the vector we want to look at is this sort of like half extent along the x or something like that. Right, or maybe we'll do half extent. Yeah, let's do half extent on the x. There we go. So it's in view space, so we can never catch up to it. But yeah, so it's from the center there to the edge of the box in view space. So it goes into the middle there, yeah. Cool. So I'm glad we corrected that API now. So let's go ahead and work on the 2D API. So we've already made the initial, this is all I already need, but I have had a thought about how I want this to work. So I think we need to change it a bit. So so we're going to be using sign distance fields because it's just an easy way to draw a bunch of different shapes. So we'll do the same sort of thing. It's not going to be optimized. We're just going to, every pixel is going to get a list, and it goes over that list and checks to see if that thing can draw there, and if it can, it renders it. Now, the problem is when you have multiple shapes and they come in, because it comes from the CPU and GPU, the GPU is very unordered. So, like, the CPU is only ordered if you execute on one thread, while the GPU kind of has, like, you know, thousands of threads, right, in a sense. It's not literal, but yeah, in a sense it does. And the order that things can get appended to arrays is not deterministic. So in order to bring order to that chaos, we need to add some form of parameter here which allows us to sort them. So essentially we just want to render the closest thing. So I think, so first of all, this needs to be a center position and then half dim. Then we probably want to also have like a depth value, I guess. Or a layer. Maybe depth is probably fine. So this means when you debug draw from shader code, then you're not going to have any problems. Or will you? I wonder how easy it will be to do this though. Maybe... Yeah, it should be fine. Yeah, it should be quite easy to do that. And maybe we'll use a float. So border thickness, color, yeah. So we'll still do a min-max ABB thing, because they're kind of nice as well, having that possibility. Depth. So circle will be a position, and then a radius. These are half dims. Then a vector will be a position and a vector. Okay. Right, I think that's good. So now I just want to edit the API, and then we can go ahead and write this shader. And this should be pretty straightforward because I've already done one of these things before. So let's find what this API is. So there's a CPU version. So we need to add, I think what we'll do is we'll turn this one into the position or center position and half dims. Yeah. Oh, wait. And then use a depth. Let's copy and paste that to all of them. Oh, okay. Right. So center position, half dims. Then there's another one, which is a depth. Then that needs to be 8 because we've got 8 words that get populated in the buffer now for this draw command, if you will. And then so we added, if you remember in the header file, we made this be a center position and half dims because that's usually how I do it, especially in shader code. But we sometimes want to min-max as well. So we're going to have that option too. So that one is probably just going to call into... Yeah, I think I did it. Yeah. You basically see something like this. So I've already done it for the 3D one. Let's do it in 2D. And no Z test. There's a depth. Half dims in, yes, that'd be a min, max take min times 0.5, half dims, then min plus half dims, and then half dims. Then that's say times 2 instead of 3, vector 2s please. Alright, and then that's a min-max, because we don't have overloads. And we're probably come with that anyway. Nice, so there's the 2 functions done, just 2 more left. We've got to up the allocate words by 1, and then we're going to populate the depth. Into there, same thing again, depth, and then up this by 1. Cool, so that's really nice. That's the CPU side done. Now it's got to do the GPU side, so it's very much just the same job we just did there. So draw 2D ABB. Now, so I plop that one in there. That's that one there. Let's copy the function prototype here. Now this CPU one worked with pointers. We don't have pointers in GPU, so this one obviously works a bit differently. But yeah, this is kind of the same sorts of things, really. Half dims. And then depth. Awesome. So we need to add that depth parameter to this function and this function. And now we need to up these by 1 and then insert it accordingly. Now, wait, did I put it in the... I gotta put it in a consistent place. Right, I must swap these around the other way. Oh no, radius first, yeah. Yeah, that's right. Oh, I don't think I updated everything correctly. Let me just try, just look around quick. Oh. Right. So 5, 6, 7. I think I did. Yeah. Okay. So I think we're ready. What language is this? This is C. So basically we use C in the CPU and GPU code. I've got a custom C compiler called HCC, which compiles C to SPIR-V. It's a subset of C. There are limitations. So it's only for Vulkan and it only works. It doesn't have pointers, no unions. It has strings, kind of, but only for printing. Yes, there's restrictions, right? But for the most part, semantically, there's lots of things that are the same. You do vertex shaders and pixel shaders and compute shaders. So yeah, it's all super cool. So we share like a lot of code and data structures between CPU and GPU without any problem. Sometimes we do have to, like in this drawing API case, make two versions of functions, but I've not really done it anytime other than this, really. But yeah. So we're gonna now write a shader. So this new shader is gonna be the draw 2D. So we'll copy the draw 3D and we'll change it. So make the 3 a 2, and then that's it, right? Not quite. So the 3D one used ray tracing. So we're going to probably do a similar thing, but in 2D. We use sign distance fields instead of ray tracing intersections. No depth texture. So here we go. So we're going to do an 8x8 grid within the thread group. For crying out loud, what's going on here? When did that happen? Oh my days, I'll put that back. I don't know when I did that. Right, anyway, so back to where we were. So effectively, we don't have array because it just is the pixel coordinate. What else? So we do draw 3D words count. How many words are there? So a word is just a 32-bit integer, and we have an array of words. And because we have a variable, because when you draw a shape like when you add a bounding box or a sphere, they have a different number of words which hold the parameters that are passed in. So as you can see with this 3D one, we used to encode 3 words, and that would have those would be the flow. That would be a vector 3. We have to do a similar thing here where we yes, the first word contains how many words are in it's like a header word, basically. It's a header. How many words follow this header for this shape? The Z testing doesn't exist on this one anymore. Where's the draw 2D? Yeah. So there's no depth involved. And then in the low 16 bits is the type. So shape. What days? 2 seconds, I'm just getting a phone call. Be right back. Right, welcome back. Welcome back. And I lost my chat now. Right, there we go. Yeah, so draw 2D shape type. So what did we pass into the word buffer for the axis line bounding box? It's right here. So the first two words after the header word is the center position, then half dims, then depth. So there'll be a center position. So basically per pixel, each thread in this compute shader gets a pixel. We're going to go over every single thing that is going to be drawn and see if this pixel wants to draw it, or like if it's over this pixel basically, and it can be drawn, and then it'll draw the closest thing that it finds. We can speed up in the future, but for now we just want to have something that works. And we already do have a similar thing in the UI system with Mave 1, but this is specific for this debug drawing. Border thickness, we need depth to come out as well. Depth, that is 5. Then at 6 is going to be a border thickness. Okay. Okay, this is going to be good. So, oh wait, is there a color? Oh yeah, 7's a color. Right. So we're going to use sign distance fields to do this. Let's go ahead and pick up some 2D SDF functions from IQ. We're going to have a bit of a play though, because what we want is a bordered bounding box. But if you make border thickness infinity, then no longer bordered. So there's tricks you can do to get that to work. Well, actually, I've already got one of these actually. Wait, we don't want a rounded one. Yeah. So basically you want this. Crying out loud. Right, I thought it was a shader tool link, not really. So you want this, but we can make it bordered. There's a trick you can do. Times 2. So this is the half extent. All right. So that's the offset from the center position. This is the half extent. Sub ABS flow 32 times 2. And I'll get you a F32 times 2. And length min, or it's a max, isn't it? Was D with a scalar argument, so you do it with an S. Then sure. Wait a minute. We're in this right. So it's plus a scalar. Max min. They're on scalars. Oh, length plus. Right, I see it now. These are all just scalars. Cool. Sure, I think that's right. So we'll call this like SDF ABB. So what we need to do is that's not a bordered SDF. There's some tricks you can do though down at the bottom. So there's a thing called an onion. And I think that's what we want. See, I think we can. Not all of them want to have a border though. I think this circle doesn't, but it's just this one. So I think we can just do this and add it on the end. So this is the way we have the border. So we'll call this like half dims. We'll add a border thickness. So this is where the border happens. So you'll call it SD, I guess, sign distance. And then you'll say return SD absolute of SD take border thickness. I think that was, so this is the border basically. Applies the border. So you'll say bordered ABB. So what we can do is now plug in all of our parameters we fetched out from the buffer. And we just get the SDF value back. So here's the sign distance. We need the center position from, sorry, the pixel coordinate relative from the center of the shape we're trying to draw. So if I get up the drawing program, we can see what I mean by that. Rather than just words. So basically you have your bounding box and it lives on a screen, right? When you're drawing this shape, so, sorry, we've got a thread per pixel. Say we're drawing this pixel, we come across this shape. What the P parameter is from the center is this vector that we're drawing, right? From the center of that to the pixel. That's the vector you pass in. And the other parameter is the half extent, which is that vector, right? And then it works out the sign distance field from that. Oh, sorry. It works out what is the sign distance from that point, obviously, right? To the edge. So P, so you got your, so you coordinate there. I guess I had a thing called coord. Let's go make that one again. Yeah, chord is what we want. We want to work in floats. So now we've got a floating point. We're going to do a subtraction. So we're going to go towards the pixel coordinate from the center position of the shape. And that's how you work out P. Then you put half dims in there. Now you're going to put in the border thickness. And that will produce our sign distance field. Sorry, our sign distance from the edge. So only if we are negative, that means we're on the inside of the shape. We don't bother any anti-aliasing here because it's just debug stuff. So we're on the inside of the shape. Awesome. We kind of have a depth as well. So what I want to have is a depth or closest depth. So that would be infinity. And then what we're going to do is say, okay, well, so we don't really want to do any of this. If the depth, right, that we read out from here is less than the closest depth that was where we found for this pixel, then actually bother doing any of this. And then if that works out, we are now the closest depth. So what does this also mean? We're also the closest color. And that means we want to now probably It says unpack, so I guess we will unpack it into a float. Yeah, I don't know why I did that. It's anyway. Because it's not colored. Let's just make it a U32. So closest color is going to just be color. Right, so that's the access line bounding box done. We might as well just plug it in, see something, and be like, oh, that's cool. And then do the rest. Because, yeah, the rest will just be another version of this one. So let's just get it all up and running first, I reckon. So if we have a color that is not completely transparent, well, let's just say color 32A. Is that even a thing? I think it's a thing. If that is a non-zero value, meaning it has some form of... Yeah, we didn't have transparency anyway. Yeah, I think we're just going to ignore alpha, I think. Yeah, let's just say if you have a closest color. Intensity... That was for the lighting, we don't have that anymore. Yeah, so we need to do the BRG. We need to do some swizzling. We need to convert it to BGRA because of displays. Nice. I guess we will unpack it. Unpacked color equals unpack U8 times 4. I could probably have a much shorter name function than that, but anyway, closest color. We want to do the BRGA swizzle. Then we want to pack it back in and send it out to the screen. Right, so I think that's everything we need. Hit compile. Something doesn't work, obviously. Needs to handle these compile errors. Chords. Alright, some of these are float 3s for some reason, or they're vector 3s, right? So weird. Okay, so let's plug this in GPU side. We need to do a draw 3D. Find the draw 3D shader that gets called. Somewhere around here. Right, here's the draw 3D render. We're going to now kick off a draw 2D render. And this goes after the 3D render because it's always going to draw on top if there is any. Yeah, so we just launch it like so. There we go. So we won't see anything because we haven't put anything in the buffer. So we need to go ahead and put that abandoned box in. So if we go over to the prepare clusters setup, what we'll find, prepare clusters at LOD. This is where I've got the debug code already for the 3D stuff. Now we make something into screen space. Top left, top right. Yes. Yeah. See, floating points probably. Yeah. here as float. That's good. So we've got them here as float, right? They turn into screen space. So we should be able to just do draw 2D. So this is in show decode, remember? ABB. And we want to use the min-max variant. So we pass in bottom left, F, top right, F. Then we pass in something with depth value. I guess we're passing this 1, or whatever, I don't know. Then a color. Wait, there's a border thickness. Border thickness, let's just try 4 pixels. Then we'll do a white color. Just because it's easier to do that, I think. Or maybe do like a green, I don't know. Okay, so here we go. We should see stuff on the screen now. Right, so not seeing a green on the screen, it's more of like a blue. Definitely some funny business going on. And it's all the way up there. Wait, what is even that about? So instead of using a value that we've been given, instead we're going to hard code one, and we'll work our way towards this expression. So let's just do center of the screen. So center of the screen, I think, so we hard code it as 1280, so 640 by I think it's 720 or something. I don't remember that. I picked a really dodgy resolution just to sort of hard code it. It's nothing meaningful. 960. So what is that? 3. Where's that? 480. Yeah, 480. Right. So 480. So then let's say, hey, it's got a half size of like. Oh man, I copy pasted that and ruined it. 200 by 100. I don't know. Right, let's give that a go. Right, so clearly it's not working. Wait a minute, did it even compile? Okay. Okay. It seems to behave differently as we move, but it's hard-coded. So there's something kind of fishy going on. Overthink about that. So what dispatch? Draw 3D resource index. It's using the draw 3D buffer instead of the draw 2D buffer. So it's actually picking out parameters which came from the other buffer, hence why these ended up looking like they were moving and were not green. So that is why. Let's just try that again. And there we go. So there's our green box with hard coded, which is really nice. So now let's switch to. So let's have a bit of a play before we switch to the hard coded ones. Draw 2D. ABB. Let's up that. Let's whack this at infinity and hope we get something that's sensible. This is the border width. No. So that's not good. What we need to do now is make sure that the expression that is used to create this is not bigger. So what is this? ABS sign distance. Take away this. So then you need to say, hey, take the minimum between. You don't want this to go take away more than the SDF itself, right? Wait. Is that right? I've just said take away infinity. No. Probably the half dim. No. The biggest half dim, maybe? Well, you don't know that's the thing. What you've got at this point is a signed distance from the edge. You got a signed distance from the edge. It could be anywhere, right? It could be here. And you got distance from the edge, but you don't know it's there or it's over there. When you have a distance, it basically gives you a radius of where it could be from an edge, but you just don't know, right? When you just have a distance. So it's saying, hey, take the absolute of that distance. This would be -2 or something. I don't know. Because it's on the inside, it's negative. And then you're saying, okay, make it positive. Then take away the border thickness. And then that will be, if it's still negative, then it's at the border. Basically. So how do we make it so see, I'm not sure if that's gonna work. No, I just made it 0, didn't it? So what could be the trick that we could do to get that to the absolute let's take a Volvic break. Got like the best water. The volcano water. So good. Laptop in charge quick. Chuck that down there. So if you've got this, like, as you increase the size of the border, it starts to get to the point where the shape would grow on the outside because you've just increased it so much. Because you're allowing any distance Yeah, is there a way that I could I don't have a time variable that gets uploaded. Maybe I could show, yeah, let's add a time variable to our globals because I want to show this and animate it. Then you'll see. So where's the global? Here. So let's just upload a time in seconds. Do we have a delta time somewhere? Right, yeah, just pass in 1 divided by 60. That'd be good enough, right? Sure, that's all a bit hacked. But anyway. Yeah, we do have a delta time outside the function somewhere. I don't know why I've hard-coded it there, but maybe it's before we had that. But anyway, delta time. Isn't she lovely? So time, seconds. So you're adding 16. That's in Yeah, it's in seconds, I think. Wait. Right, I think that's ought to be good enough. So we've got time in seconds now. So if we get that global, we just fish it out here, right? Right, why do we do this draw 2D ABB, right? So we'll chuck it in here. Graphics, global. And I want to get the global out there, which is time, seconds. So every second it will increase by a pixel. That's a lot of seconds, so let's times that probably by about 16. And let's just watch it animate a lot quicker. So now you'll see, oh, it's growing each side. And then it just only grows on the outside. Right. That's not what I want. Right, so I've done this in the past actually. So past me has probably thought about this. I think I have a border in my UI code. Where is my wonderful UI code? That's color bordered. Isn't there a way of producing a border though? No, I didn't add, did I add it to this, to one of the ops? Yeah, I've got this crazy sort of SDF, essentially virtual machine. I called it outline. Right. Thing that I do for UI. It's kind of cool, it's very flexible. Be quite creative with it. But yeah, it seems to be doing the same sort of thing. Right, so it grows on the outside. We don't want that sort of, we don't want like an outset, we want like an inset one, right? So I guess if we just take the, or we go back to that sort of border thing here. So when you say absolute of sign distance field, then you take away. You're allowing anything on the outside to then become the border, right? But sign distance, so you're allowing for anything on the outside, which is a positive value, to become a border, right? When you say take away, right? What we want is to say no. Anything that is on the inside as a negative sign distance from the edge, right? Then decide if it is by the border thickness. That's actually quite easy. And it probably requires an if statement, but you probably do it without an if statement if you wanted to. So that the basic idea is like, only if it's negative, am I border thickness away from the edge? And if that is true, then yeah, then, but it won't be a proper sign distance. I've got to figure out how do you make it a proper sign distance though, because that's getting conditional, whereas what you want is like a So imagine if your border thickness is like 3 or something like that, and you have a 2.5. So you're negative 2.5 from this edge, but then you're like, oh, but my border thickness is 3. So now you're, rather than it being negative 2.5. It's now actually negative 0.5 because you're 0.5 away from this edge. Because that's how sign distance works, right? What's your closest thing? How close are you to the nearest edge? And I'm on the inside, so it's negative. This would be outside. So when you do that onion thing, it actually is kind of not really an SDF anymore. Because you're sort of... Because if you're saying negative 2, ABS positive 2, take away 3, negative 0.5, actually, yeah, that's right, isn't it? So it's as if like you need a bit of ABS in going on, but you probably don't want to include maybe you only want to ABS if you're negative or negate then. I don't know, let's just give it a go, see what happens. So I think you'll say if, it's probably a better way to do this. If you're positive, oh sorry, negative, then, okay, so if you're positive, then return SD. Then you know you're negative, make it positive, take away thickness. Probably be what we want. So now it's growing inset, yeah? But how does it go when we reach here? Right, it's fine. That's kind of what I wanted. I don't know if it's really a correct SDF, so if we tried to do any more SDF operations, I don't know how that would be. But it basically draws what I want. If the value is infinity, right, if that border is... If the border is, you know, is set to infinite, then it'll probably just be fine, or a very large number. Then that'll probably be okay. There you go. Still renders. So that's all I wanted to know. So I'm glad we sussed that problem to keep the music going, and I'm kind of disappearing into the top. So that's cool. So let's switch over to using the min-max version. This is center position and half extent. We've got a min-max version as well, because that's kind of useful sometimes. And we'll see if this is the shape we're actually trying to debug next. And this is the supposed screen ABB. I know, something feels really off about that. And this is the screen ABB that we apparently used to say, hey, these tiles have the spheres in. And it seems like it's the y-axis is can you see the glitching happens when the x-axis is wrong, but the y-axis can be wrong for some reason, and I don't know why. So that's something we're going to be investigating soon. I just want to finish this 2D drawing API, and oh, look at that, that's interesting. But yeah, the negative values definitely behave differently. Whereas this one wraps all the way around there. So the way I'm making my screen ABB is definitely a bit weird in the negative dimension on the X, and the Y is just messed up anyway. That's cool though. So now we can visualize these things. Debugging should be a charm. Are you a graphics kind of guy? I'm becoming a graphics kind of guy. I'm learning more and more graphics by doing this. I do work as a graphics engine guy. So yeah, I kind of started as an engine guy, and then I moved into graphics. So I'm just kind of like, yeah, getting more and more knowledgeable about it. But it is a big field and kind of complicated. But yes, I guess I'm a graphics type of guy. Are you a graphics type of guy there, Amuga? And welcome to the stream, by the way. So the next one we want to do is the circle, right? The infamous circle. So this one's going to be dead easy as well. Should be finished with these. Not so long. I think there's only so circles we want to obviously use to debug like points and, and then like obviously vector. And then like that's about it for the 2D stuff. We are going to probably want to do more in the future, but for now, these things are just going to be enough. Right. Hey there, Ray. Ray. I'm aiming to get a graphics role. Currently learning OpenGL. Love the intersection of art and maths. Yeah, it's yeah, it's kind of cool being able to learn some of the maths and be able to express yourself artistically that way. Yeah, it's kind of nice. I'm not really a maths person, but I'm kind of learning it as I go. For me, it's kind of like it's a very because I'm kind of artistic, and it's a way for me to learn maths through art, right? Or yeah. So achieving art with maths, but learning maths at the same time. So it's kind of cool. But yeah, I've been more on like the engine developer type of side. I've been learning that for a whole ton. But graphics has always been that thing where it's like I just get lost in it. So I'm just glad I'm doing a lot better at it now. I'm a game developer and also graphics. Nice you asked. No worries. Yeah, I'd like to see what you guys are up to. Who my audience is. And because, actually I get a lot of helps on stream sometimes because people just know a lot more and can lend a bit of knowledge in there as well. But yeah, so do you like work full-time as a graphics engineer, if you will? Amiga. But yeah, also Rez, keep up with that portfolio, keep making stuff that's demoable and keep going around and like work on that side project and then like when you got to a bit where like, oh, this is cool, try and get a position as like a junior or whatever and do a round of that, and if you don't quite pass, if you don't quite get a job, you get close, then just go back around again and work on your side project, get it to the next level, and then I could go around again. You'll have like some more ideas on how to tackle the interview and keep going and you'll get it. There's definitely like a lot of what I find kind of annoying about graphics is there's a lot of like kind of they're not really secrets. There's a lot of like hidden knowledge, if you will, where things don't really get easily shared or the knowledge doesn't get disseminated easily to people. It's kind of like hidden. And the people who are sort of like in the game and work in graphics every day get exposed to this information and they just sort of keep adding it to their pool of information. And so when you speak to someone who's got all of that information and they can sort of just easily sort of like communicate with you, you could, pick up on things quite easily. But if you just come into graphics and try and learn this very complex well of things, it's very easy just to get lost in the complexity, which is 3D graphics programming. So, yeah. The dissemination of information definitely is needs some work, I think. A Sorilla got me interested in the job and gave me a generic pathway for it. Cool. They said there was a lot of gatekeeping law. Yeah, it is very strange, especially like when you think of some of these conventions that happen. I think it's like SIGGRAPH or whatever. You have to pay to get like a ticket, and there's all of these like these talks that you can watch online and get slides for and stuff, and that you wouldn't quite have access to if you didn't. And it's just all the people who are at the top of the game giving the talks. So yeah, it's kind of sad. Hey there, Perry. How's it going? Happy Easter. How you doing? Good to see you. How's the Easter break going for you? Oh, Perry, yesterday I went paintball. And oh my days, it was like a 50-50 experience. Sometimes I ran out and I just got absolutely slaughtered by paint. Other times I ran out and my days, these people got annihilated. They weren't quite taking the hits, all of them. It's classic paint. If you go paintball or airsoft, you know, people don't. It's the classic, like, people feel the hits or they don't feel the hits. And it was paintball. It's got a splat, so people are like, "Oh, I felt a hit, but I didn't think it splatted." And then you look, it's like, oh, okay. So there's always a delay of people getting splat. So as soon as that person just gets in my sight, I just launched 10 bullets, or sorry, paintballs at them, and just so they know they've been hit, you know. But yeah, I got a lot of bruises though. But yeah, paintball's fun. I was actually surprised I was able to still do it. Yes, lots of bruises. Oh, I got a right one on my knuckle. Yeah, I'm gonna switch my light on. Excuse me. Oh, yeah, so I don't know if we can see this. Oh, it is. Yeah, I got a bit of one on the knuckle. Lovely, innit? So that one came from like we had to get this brick to the other side. It was on this bridge. It's called D-Day, and you're sort of trying to storm you just got like unlimited troops and trying to storm their base, and you had to get this brick to their base. So I was the person who, when I got the brick off the bridge, and no one was guarding it, so I just went and grabbed it and then threw it to someone, and they ran it round. But as I went to go run around and help with them, I just got plastered across the bridge just with paintballs, and all just, yeah, really really took my finger. I was like, damn it. Yeah, it's good fun though. Mm-mm-mm. Good mate, how are you? How's Mrs. and Kiddo doing? They're doing good. They're doing good, thank you. Yep. Wasn't bad. Just getting back in the swing of things. Been at home for a month now on the holiday. Um, but yeah, they're doing good. The boy's still not crawling. He is just sitting up, but he's good. He's happy though. He likes to play with his toys. He actually started feeding himself with the drink today. I accidentally left the drink on the table and he just picked it up and started drinking it. I was like, oh, okay. This boy can feed himself. Do we have a border? No. Oh, did I do borders for circle? See, I didn't do a border for a sphere, but it might be quite nice, actually, for a SDF. Sphere. Yeah, let's just do it. Let's just do it. So, radius. Color. Right, so if this is the closest shape for this pixel, we'll do a bordered circle. So bordered circle again, P, relative from the center of the shape, right? A vector from the center of the shape to the pixel. Border thickness. So I think this is like len of P, take radius. Wait, what did I say center positive? I was talking about the other one. take radius. I think that's it. If memory serves. You'll end up P, take R. Boom. So, yeah, this negative will do this trick to make it a border. And I hope it's that easy. Plop that in there. Radius. Okay, so let's try this one out now. A, B, B. Okay, so we're gonna do a circle, and it's going to be a center position, so I guess let's just hard code it. I can't be bothered to. Yeah, so let's just do 640 by 480, that's the middle of the screen. And we'll do a radius of like 32 pixels. So it'll be 64 pixels in diameter. And we'll do a nice, what sort of colors do I have? Let's do a horrible blue, because I know that one exists. Well, we do have cyan though. Let's do a bit better. There we go. So we can do these nice on screen. Well, okay, they're not nice. They've got horrible aliasing going on. But, oh, that's buggered up my, the color of the other one there. So it seems like we've overwritten some of the data. So if we take away that, you'll see that the green this is green, this green bounding box. So this means that the circle is clearly overwriting some of the data. So I think we let's just double check that. So this is 8 words. This is the CPU side 1. GPU 1 says 7. So clearly we didn't allocate enough words. Right, that's 8, good. So didn't allocate enough words there for that op. So now we just upped that, fixed it. So we can do like a screen bounding box, which is nice, just about there. You know, part of me really wants to just I don't know anymore. Have a mouse position like parameter be passed into the shaders. I think it'd be really useful. I don't know why I've not done it yet. I keep saying I need it, but I never do it. Should we add it quick? We'll make it a float as well. I don't know. What's more useful, a float or an int? So, OS, virtual mouse position, that'd be kind of nice, wouldn't it? So that means we should just be able to literally just plug that in here with a simple call to the globals, and then we'll have this just follow the mouse. And it goes the wrong way. Ooh. That's something to keep note of. Ah, no wonder why it was going the wrong way. The box was going the wrong way. Ooh, because I didn't flip the y-axis when I wrote out the... Yeah, I didn't flip the y-axis in the shader. No wonder why it was off on the y-axis and didn't seem to make sense. I didn't do the classic... so because we make like, in Vulkan... everything is addressable from the top left, but we're a bunch of bottom lefters, so we've got to flip the coordinate somewhere. So when we write out to an image, we need to make sure that we flip the coordinate upside down. Hey there, Sake. How's it going? Right, so now these will actually behave. Alright, so now the box is kind of like, we're seeing the visual artifacts where they come from now, you see? The screen bounding box is just completely wrong. But yeah, now I've got this following the mouse, which is kind of cool. Look at that input lag. So you're getting latency from like, I've not read the latest mouse position, and then like the whole frame gets generated, if you will. CPU. And then it gets sent to the GPU, right? And then the GPU renders it. Like, does all of the rendering as well. And meanwhile, you've moved the cursor. Yeah, I don't know how we can make that better, because surely maybe we can just poll the events a little bit later in the frame, and that should fix it. Because how does the compositor like put the mouse in the right place? But yeah. Anyway, that's cool. So we've got 2 debug shapes done, 1 more debug shape done, and then we can move on to just debugging actual GPU code. So it's the vector, position vector, and whatever. So what the scientists of field shapes want to use for this is the orientated box with a triangle, right? Probably one an isosceles, right? Because you want to, or maybe just an equilateral. Yeah, equilateral. Or you just do your own triangle. But yeah, equilateral is probably good enough. So why don't we take this code and we'll do an SDF arrow. We'll make our own. It's going to be amazing. Yeah. So the arrow is going to be a good old P sample point. And then an A and a B, so we'll call it a start and an end. Hey Cranston. I remember reading about hardware cursors. Don't know what that meant, but it made me know software actually knows most current cursor position. Yeah. Because I wonder how the compositor... So obviously the compositor is going to be the thing which takes your texture, right, if you will, your swap chain screen texture, and then composites that onto the final screen in a window, right? And the mouse gets rendered on top of that, right? So they obviously do some GPU commands, right? So they're probably able to grab that mouse information and just and update it just a bit quicker than you are, right? They're probably able to update it just right at the end there. Like, so when the compositor queues up its command, it's maybe able to, because I don't know how because the compositor definitely uses a GPU, right? So they've got to send it from the CPU somehow. The difference between hardware and software cursor is that to make it smooth, the cursor is rendered different from the polled mouse position in hardware. Interesting. Different from the polled mouse position from hardware. Right. Right, because if you didn't render it differently, it's just more interpolated. Because otherwise it looks very sort of like jagged or whatever. Oh my days, there's a theta? What? There's a theta involved in here? Wait, okay, that's what I want, a segment. Right. I don't want no theta. Yeah. Right, it's less maths, so start end and thickness. Oh my days, comma operator. Ugh. Right, now get ready for my ugly maths as well. Ugh. It's alright, it's readable. Wait, you clamp in a float. Dot product between those boys. Thank you. Div floats instead of doubles. Len sub. What is that? H. That's a mole less. Scale a vector for me, please. Thank you. Alright. So that gets our sign distance. Keep with the style and do like no. Yeah, short names. So what do we want to achieve from this? So the thickness, you do take thickness, because if not the line segment is literally like a pixel big. And now increase the size. You know, negative is inside the shape, so if you take away stuff, just more stuff becomes inside the shape. And that'll make it rounded as well. So that will get us the line segment. The next thing to compute is the arrow tip. So maybe we just do segment, and then we'll do the equilateral triangle. Yeah, I'm not sure if there's a way for the graphics card to read exactly where the mouse position is. Like, that just doesn't... I just don't think that's the case. Like... Right, okay. So the way that I think it will work is you can transfer data from the CPU to the GPU. Like, that's the way the GPU gets data. There is obviously direct storage and whatever, which apparently reads stuff from disk now. But, and I think you can do some stuff with mapped files that I've seen, where you can sort of map a file into the I don't know. I think there's some stuff that you can do with mapped files as well. And the GPU can read from a mapped pointer. But besides that, the CPU always gives the GPU information. So if the cursor, yeah, the cursor information always comes from the CPU, basically, from what I understand. Yeah, I guess so. Yeah, really legacy it must be, yeah. If so. Right, so what's a triangle do we want? What's an R? Okay, so this is obviously, it's not going to get rotated. Right? Right? You got to rotate P if you're going to rotate it, right? Why do I not see no... Is it the dark theme? Guess not. Oh, shade is broken. So yeah, I think you've got to do a rotate of your point. you got to use like a 2D transform, if you will, or you could probably do it with vector maths. So I guess we'll be filling. But then again, I need theta. You need an angle. And they're not good. So we'll probably just do the more complicated version. Wait, what is Q? It's isosceles. I think that was more upright, isn't it? Why isn't this working? Oh, shaded size is broken. What is on Brave? Yeah, so I guess so Q probably is like X and Y size or whatever, whereas this is like 0.123, and this will probably be the one that we can just use. Like we'll be able to do a bit of maths, and I don't know, is there another, there's probably a simpler way, but I don't want to screw on with rotation. So I think I might just do the more complicated shader code, I reckon. Yoink. Right, let's plop that in there. Good old P0, 1, and 2. So obviously just points of the vertices of the triangle. Nothing too complicated except for this whole code we've just copied. Yeah, maths. So these are the edges by the looks of it. Alright, let's just yeah, so you get the edge vectors, right? So I need to do the old get rid of the operators. Now you get the okay. P take another sub, right? Yeah, just declaring more of these buggers. Right. More subtracts. Let's roll. So we're subtracting. So we're getting a vector towards P from the edges. Now, so these are vectors going towards P from the edges. So you can imagine you've got your triangle. You've got your sample point up there. Your vectors going to each of those like that. And then you've got the edge vectors, which are just like that, right? They're the edge vectors which represent those edges like so. So they're your edges, they're your vectors towards the point. These are, right. So these are all scalars, right? Because we're doing some dot products. Good old dots. So dots between, so this is squared magnitude of the edges divided by so edge, so dot the edge vector with the vector going towards the point from one of the vertices. Interesting. And you multiply that by the edge vector. I don't know what this means. I just know what the variables are, but okay. If you draw it out, you could probably see like, oh, that's what's happening. But yeah, so this is clamping a floating point. And then you're scaling this vector by a scalar. and then you subtract, finally subtract from this sort of vector going towards the pixel from the vertex. So yeah, what are you producing here? You got an edge and you're scaling it by how much, something to do with like how much this, Right, anyway, get you these P, Q, zeros and that. And then what is all this doing? So you get your sine of that float. And then you work out your distance with all this. Right. I see what's going on. So you're getting your edges. Thank you so much, Egotist. Appreciate it. Less than 3. Thank you. Less than 3, you too. Right. Appreciate the sub. Thank you so much. I pattern match .ab divided by square bb to a projection. It returns how far does A goes in the direction of B measured such that 0 is at the origin and 1 is at the B. Ooh. And 1 is at B. Oh. Wow. Okay. How far does A go in the direction of A, but measured in 0 going towards A? Going towards B. Interesting. Yes, the way they look about it is you've got these sort of edge vectors and you've got these sort of vectors that go towards your pixel point or whatever. And you're basically saying like, you're using, I think it's going to be using 2 of the different, no, it can't be. Yeah. But yeah, it's somehow basically working out the distance to each one of these edges independently and then finding the minimum one, right? And it's using the vertices and the edge vectors to sort of work that out, basically. But yeah, so I do kind of understand what is kind of going on, but yeah. I wouldn't be able to write this from scratch. Be like, oh yeah, that's how you do it. So min f32 times 2. And then your, right. Cool. What did I lose? Oh, I think I didn't. Nah. I think close this. No. A start B and ooh. Square root. Okay, there we go. So now we've got our 2 sine distance field functions that we use to construct a vector. We've got a segment and we've got a triangle. So we'll just plug in the segment first and we'll do the maths get the segment in there. So we're going to copy paste the circle one. Well, we'll copy paste the ABB one because that's got kind of more of, it extracts kind of the same sort of parameters that we want in a way, like data type wise. Vector, so we've more of got like a start position or a position that we start from, and then we've got a vector that comes out, and then we've got a depth. We've got a border thickness, instead we've got a thickness and then a color. So segment. Hey there, glorious sir. Doing good, doing good. How you doing? So just finish up on this debug drawing, and then we're going to be able to debug our LOD and clusters. And so the 3D stuff is all good. We're just finished, literally on the last one of the 2D now. So yeah, it's getting close. Oh, sweet, thank you, Laura. So B times clamp. Wait a minute. I get to learn some things. Right, so B times clamp. Right, I see. Yep. So you're talking about this expression here. Is a clamped version of A that lies on line segment 0B. Right, so you're the edge vector of E0. So that's the edge vector. Right, you're doing, so how much does that lay across there? Got it. So you've got this edge vector, and you're saying how much does this, so here's our point, and this vector comes out from here going towards there. You've got this edge vector which goes down like that, and you're saying how much does this go down there or whatever, or the other way around. There's some subtraction kind of involved. Yeah, I kind of get what's going on. But yeah, I need to learn more on my maths to be able to write this stuff rather than just read it and just be like, you know. Rightio. So I want to plug in a segment. A bordered segment. Segment. So this will be the position. Then the second one will be add of float 32 times 2, position, and vector. So that's the end one. Then there'll be some form of thickness. Yeah. So let's just view that, and then we'll add the triangle bit on. And I think we're going to take some of the stuff from the 3D one. So let's find the circle code. Right, we did the circle here. Let's do another one for, this will be fun. So let's go towards the mouse position, I think. Yeah, we'll go, maybe we'll do a vector. So maybe we'll do a, let's say, hey, from the center of the screen, so I guess I'll just hard code it 640 by, draw a vector towards the mouse position. So there's the vector to the mouse. position. But you usually just have like a position and then like a vector. This is the vector that you're plugging in. Very rarely you'll do a start and end position that you want to draw. Or maybe I should have both. But anyway. Then we do like a depth, I guess, followed by like a thickness. I guess it's still like 4 pixels. Oh, screw it. So not cyan. Let's do a yellow, I guess. Should have more colors. Right. I didn't pass in my P. So the vector towards the pixel from the center. Wait. Ooh. From the center of the... Wait, is there even a P here? It might be an absolute. I don't think it's from the center anymore. I think it's actually just, it might just be coordinate gets passed in. Because P would be, yeah. It's different. It's just coordinate in this case. It's drawing a circle. Zoom. Right, that's not a vector. Why? Did we, right, this is not finding anything. So yeah, I think we've just, yeah. We didn't make it. So that's the CPU code. Here's the GPU code. There we go. Cool, so again, our line segment now. That's being drawn towards the mouse from the center of the screen. So now I just got to get the arrow tip on there. Now, something that I do need to think of is like, if I increase the thickness, yeah, I think we've got to do some of the edits that we did for the 3D version of this. And that is, yeah, if we increase the thickness, what you'll find, so it's a thickness of, no, 16. You'll find that it's, yeah. The length of the line is actually bigger than the vector itself. So what we need to do is actually move the start kind of off based on the thickness itself. So in the vector, in the 3D vector code, we do this sort of like capsule start, where we add the like, we project the thickness across the vector and then just sort of like move the position a bit. We need to do that as well. We need to do something like this basically. And probably this sort of thickness check. So we'll bring that all in to the 2D vector one. Wait, where's the end length from again? It does the len. Yeah, we probably do that as well. So if it actually has any length, so we did this sort of code here where we're saying, okay, the cone length. So I guess this is now the arrow tip. So we should call it arrow or the tip. Oh, where the hell did my thickness go? Did I overwrite that? Oh, it's here. Ooh. Oh, it's all the way down there, isn't it? Whoops. Move that. Two seconds, I just heard someone in the house. Let me just double check. My wife coming back. Right. Yep. Linux audio, everybody. Thank you for yeah. Thank you for that. So I probably would have like hit the cable. It would have unplugged the sound system and plugged it back in again. So yeah. Linux. So yeah, I hope you heard all that. So effectively, the line segment starts exactly from that pixel, and the radius doesn't make it start anything before that pixel, basically. So if you see here, the head where the mouse cursor is does have that problem. See how the radius goes further away from where the position is. So what we need to do is we need to probably apply that same change here. Although, wait. See, it wasn't a problem in 3D because it's a cone, I think. But in 2D, yeah, I don't know. It wasn't a problem. Yeah, we should probably do it up to tip start. Maybe we did. I gotta think about that. Did we do that? Yeah, I did it up to cone start. Yeah, so okay. So up to tip start because it's kind of like a tip in 2D rather than a cone. I guess, I don't know. Language. Right, that one's a little bit. Yeah, that'd be alright. So now we just got to draw the sort of the triangle that represents the arrow tip, and we can sort out the sizing in a bit and play about with it because it looks like it's popping a bit, and I'm sure I can improve that code. So it should be relatively straightforward, right? Basically, we want to compute another SDF. So this will just be the min of SDF0 and or assign distance 0 and 1. So this one will be the triangle. So I'm going to pass in the three. So you got your line segment. Then you want to basically, from here, this would be that point there at the end is known as tip start. So effectively, we need to get the perpendicular vector and shoot it off by thickness. Wait, what's it called? Tip thickness. Tip height? Tip length? Yeah, tip thickness. So we'll offset this by tip thickness and get this point here on each side. Those are our two inputs. And then we've got a tip length. Yes. And a tip length. And then so we take that vector and increase it by tip length, and that's that one. And that'll form our triangle. So it's pretty straightforward, right? So let's try that code. So you make a perpendicular. So first of all, you want to get the normalized vector of. So we already kind of do it here. So I should just call it vec norm. So that is just vec norm. Boom. So you got vec norm. Then you want to get the sort of perpendicular vector. So that'll just be vec.y negative. So you can put the negative here or here. It just changes which way it points, depending on your coordinate system. Bottom left or top left origin or something like that. One of them will go that way and the other one will go that way. But we don't really care because we want both of them. So it just doesn't matter. So then you want to get V0. v0 is simply just going to be the add of the scaled tip start. Wait, sorry. We're adding from tip start, and we're scaling from. We're scaling the perpendicular vector by tip thickness, and then you compute v1 by the subtraction of that, or the or you change this. So that gives you two vectors. The final one is going to be an add again. You're going from tip start, but this time you're going across the vec norm, right? Vec norm being the vector going that way, right? So you start from this point here, and that is tip len. Wait, we already have that one. It's just called end. So v2 is just end. And voila. So you just plug those boys in there. So v0, v1, v2. And that should be the arrow tip. Yes, clearly it is the arrow tip. It's like it's like a platform now. Oh, right. You can see the triangle, right? It's just bloody wide. So clearly the thickness, these two guys. Oh, I did vec instead of vec norm. What melon? Right, there you go. Ta-da! Arrow! Yay. So, what I want to do is have a bit of a play with this quickly. And I want to, like, it's kind of popping a bit. And I think that's a bit, it's not nice. Well, maybe it is fine. Like, why do I need a thickness, right? Like, so when it's in screen space, I don't know, actually maybe you do want a thickness, and the fact that it pops is fine. You might want to draw it a certain size, and sometimes you can't. Yeah, I think it's alright. It's just debugging errors, right? Yeah. That's cool though. Okay. So, now we can move on to actually just debugging the code. So why don't we just commit this? Yeah. Is there anything I want to test quickly? No, I think it's all alright. So let's go ahead and commit this code at least. Yeah, probably was that. Git status git commit -a. So what we're committing is yeah. Get draw 2D API working on CPU and GPU. So there we go. So that's the draw 2D API complete. So now we can move on to actually debugging the problem which we had before setting off on this journey of making it easy to sort of debug shader variables easier. Right, so now I've got this nice API. we can figure out like what is wrong with the shader. So what was working on is preparing our volume clusters and selecting which ones to render. So what we're rendering right now on the screen is we're rendering a single cluster. This is cluster at LOD 0, so it's the lowest level of detail. And we're just saying that it's got all of the spheres in there. So you're just seeing a 4x4x4 set of spheres. And what we're seeing is a yellow view space bounding box. And then this green screen space bounding box. And then this white oriented bounding box, which follows the cluster that we're circling. And then that vector in there is just showing you the width, the half dims in view space for some reason. So ignore that one. So what we're seeing is as soon as this screen space box helps us bin our spheres into screen tiles, because that's the way the renderer works, is the spheres are binned into arrays per tile of 16 by 16. So as soon as we go, so if we're in positive space, it's fine. You can see the screen bounding box that gets computed seems to be okay. But as soon as you go into negative, things start messing up a little bit, or at least towards the middle along the y-axis. But on the negative axis on the x, completely bad all around. So what we're going to do is figure out how to, I think I'm just going to rethink the code of how to produce a screen bounding box from a view space bounding box. And we'll probably create something similar, but I don't know, it's good to just go from the beginning sometimes. And have a fresh start. So let's disable this. This was clearly our problem. I'll recompute it in a minute. Alright, let me destroy that vector in 3D. I don't want that. It's annoying. I need to... Okay. So basically we've got this view space bounding box. It looks great, but we need to find a screen space version. So effectively, we just need a rough version. You know, these clusters are probably going to be like much smaller. So rough calculations are going to be off by a pixel or two, right? If compared to the axis line bounding box, they'll be off by like a pixel or two. So it's probably won't be so bad if it's rough. So if you notice, if you take this view space bounding box, the axis line one, the yellow one, you'll see that the corners sort of given the sort of projection, the 3D perspective projection, the corner that's close, when the ABB is closest to the corner of the screen, that corner is the one which is closest to the screen and furthest along the X and Y axis in that sort of direction, if you will. So you'll see the top left edge is closest to the screen, and top and left. This one here is closest to the screen and top and right. And the same for the bottom and bottom left, right? So what we basically want to do, and it kind of gets, and when you get into the middle, like as soon as you get one of the axes that goes down past the middle of the screen, that logic is, that logic can still be applied, that we've just said there in a way. But Hmm. Hmm. Yeah, but the problem is if you had, I think the way the current code works at least, is that I'm like, okay, well, if you take this back left one, this is the one that's the furthest left and down. So you should be able to construct a 2D bounding box from this back one and this near one, right? That applies there, and obviously in each of the corners it applies, but when it goes over the middle, it doesn't really apply like that, because as you can tell, this back one down here is not really the lowest one anymore. So I guess the logic you want to use is you take if it's on the right hand side of the screen, you take that sort of top right one, that bottom right one, compute the furthest bottom and top, and then you want to take the back left, and you also want to take the back left and the bottom left at the back, right? Yeah, back top left and back bottom left, and then and again compute the furthest, probably left, mm. But you would have the same problem here along the x-axis as well. You have the same sort of issue where it's just, yeah. So maybe I just need to take all of the back corners and all the front corners. Yeah, but I want to translate them all. Hmm. Because you can't take the center position of the box and turn that into screen space and take the half extent through, because that will be off still. You can still do it, I think. Um, but it would be way off, I think. But if you got them, that's kind of. Hmm. All right. So what should I do? Should I take? Should I take each of my corners? I don't take them all back into screen space though, because it's just a lot of divides. Um, Maybe it's the only way though. You could probably work it out with a bunch of if statements. No, because as soon as one crosses over like that, along that sort of y middle or x middle, it's sort of like the rules kind of change a bit. No longer it's this corner and that corner, you just produce an ABB. You could do a real rough one, I guess. Where you take that top right one and just flip it. No. Yeah, where you, what do you do? Um, where you invert it and then take the maximum between them or something like that. So you could probably take Um, Wait, then that's not the problem, is it? The problem is the fact that this back left no longer becomes the lowest bottom piece. Yeah. So the way you deal with that is you flip. You take that vertex up there. So I think it's measured from the middle of the screen up there. It's in view space. And then you probably want to invert it. No. No? Mm. Yeah, maybe you can just do it with a few less corners. Hmm. Right, I think I'm gonna take a screenshot of that one. So I can sort of just work with that. I need to have a button which disables this trapping of the... This trapping hasn't really worked out in my favor. I need to sort of sort that out at some point. This is the mouse. Alright. Let's just do full screen pick. Right, let's open that one up in Creator or something so I can just play about. Well, that's pretty quick. I'll actually open up that program quick nowadays. So what do I want to do? So, when I'm in view space and I've got this box, how do I decide to draw an ABB in screen space around that, like that, basically? That's what I want. So the maths would be, I've got this center position of view space. I know that the center position of the bounding box is kind of going upwards that way, right? It's going positive to the right and positive on the Y. So with this, what I can do is I can say, right, from the center of this view space bounding box, pick that corner. Pick the one that goes in the same direction as this vector in a sense, right? Pick that corner. So I take the sign and pick that corner on the near, and that would be your yeah, take that and pick that corner on the near, and that's your sort of your closest, that sort of furthest top and furthest to the right, if you will, right, or to the left or whatever. Now, because you have this sort of like problem where yes, the current algorithm will then pick the opposite end that's far and try and draw a bounding box around that, but as you see, it doesn't quite work. So what we need to do is we need to make sure that we take the other corner here and here, and that corner there and there. Wait, there and back there, I think. Yeah. So these two and those two to account for the... Wait, is it just the near guys? Wait, I don't think it's the back ones need to have a play in this. No, the back ones don't need to play, so we just need these four corners, and from these four corners we can do... What can we do exactly? So I need this one for the furthest left, I need this one... I need this one for the furthest top and right. but I don't... Like, I could do some maths to sort of know if I'm in this situation with some if statements, but equally I could just make these points and just do the maths. But I'm wondering if I can do it in view space without taking it to screen space and doing some divisions. So in view space before projection, you know this is the furthest right and top. You know that one is the furthest right and top. But what you're looking for really is kind of like that furthest bottom or furthest left, because you don't know, like if you're in the middle, it could actually be this guy could be the furthest left, and this guy could be the furthest bottom. You don't quite know. And this one could be the furthest left and furthest bottom. And you don't know while you're in view space. You actually need to bring back those 4 coordinates. Yeah, I think it's alright. So I think we bring back those 4 coordinates. Then that's 4 instead of 8, and that's savings. And you don't have to have any if statements. Or the other way you could do it if you have if statements, if you could basically say, well, if the... No. Yeah, you could say something like if the bottom of this box goes past the middle of the screen, then go into this different mode or whatever. Or the way you would calculate is instead of using this for the bottom, use that for the bottom. But then you got to bring more vectors through into screen space anyway. So you might as well just have a sort of a... Yeah. Alright, I think this will do it. So... Right, let's work all this out. So you got the half extent, and you've got this sort of like center position of the cluster in view space, center position, and you got this sort of half extent. So you're getting the exercise a new clip. Well, maybe I can just make that a... I can just invert the... So it's divide by z, but this could probably be... So we can improve on the divisions at least by just inverting that. Right. So effectively we want to get our 4 points. Right, so let's call them like 0.0. Yeah, but how do we get these points? What are we doing? So there's important corner, and then the other important corner. Then we want the sort of other corners that are sort of in near though. So you probably want like a important near 0.0 in view space, important like 1, 0, 1, and 2. Then you want that important far point, and you need one of those. So this would be an add. So this important offset. That is basically doing that sign thing that I just spoke about earlier, right? Where you get the sign of, so you get the vector from the center to the center of the cluster. And you take the sine of that, and you then take the half extent, and you apply the sine to it to get your important corner. And if you're over on this side of the screen, it'll be that one instead, right? It'll be this corner, but it's over there, right? So there's your important offset. So that gets you 0. Then you need to take that offset, and instead of going that way, you need to go opposite left. So you actually need to probably change the sign of the x and change the sign of the y. Damn it. Why don't I just construct... Why don't I just do this? It's going to be bloody long though. But anyway. This is very, very long. It's because it's just so damn... Right. Where's half dim x and all of this? Okay, I've... half dims. Let's make it a bit shorter. Right. That will reduce a bit. That's cool. Hey there, chat. How's it going? How you been? .y negative z. Right. So it's kind of like a multiply on the signs and a negative z though. Oh yeah. So maybe what we can do is we can just say mol this with a kind of like so we construct that sine x sine y negative 1, and I think that can be a little bit more condensed, right? Okay, so with this, so this one needs to be negative sine on the x, negative sine on the y. So those two ones were just constructed as this one and this one, right? Yes, they're on the nears. Now on the fars is basically this. So it's a far 0.0. So that would be a... We could probably just take it as a... you know what? Let's negative x, negative y, and a positive 1. So that right there will compute those 4 important things in view space. Right, that did some fancy... Anyway, that was some hack for me to try and fix with that Dinos debug view and stuff I've got now, so I can see the problem a lot clearer. So now we need to project it back into screen space. And we didn't even apply the offset actually. Wait. Min max. What's that about? Yeah, the min max will still work if you only apply the offset. Okay, so what I think we might make is a function that just a nice utility function, which just basically takes stuff from view space to screen space. I don't know. Project to screen space. So you're taking your view space, position in view space, and then you want to take in your sort of inverse pixel size in nickel plane as an input parameter. And so the basic idea is you do like you take this sort of like, this is ends up being like a signed offset, I guess. And you want to bring it to being like an unsigned offset. So this would be your so you divide it by Z, so then you're in near clip space. Position in near clip space. And then you divide that into kind of screen space. So you end up in like as a signed offset in screen space. And then you finally produce, you then apply the half dims to it, right? So I guess we can see this, right? Add the half dims. So it's just like a screen half dims, and that's just like a damn it. Good to hear, good to hear. I'm good. Yeah. Welcome to Game Engine for a game without an engine. Yeah. So we're just currently doing the rendering, research and development. So we've got kind of like the core foundations that you typically have in like any 3D game. So we've just been focusing on that really. Initially, like a month ago, I came up with a game design, which I not really spoke about on stream at all, but I will do that eventually. But essentially, we've got like a core set of things like memory allocation, dynamic arrays, and hash tables, and stuff like that. We've got a GPU abstraction which sits on top of Vulkan, which is basically creates buffers and textures and then launches compute shaders. That's all it does. We've got an operating system abstraction which has, you can create a single window, because I only really want a single window. You can attach game controllers on Linux and Windows, and keyboard and mice, multiple keyboard and mice and game controllers. It's probably got some other bits in there as well, like files and stuff, but yeah. I've got a UI library as well, which I made. So it's an immediate mode UI. Currently it's not plugged in, but it's basically there. It's all tested and ready to go. We've got like scrollable areas, text fields, single line text fields, no multi-line. But yeah, I haven't thought about localization yet, but yeah, it's basically ready to go in terms of like prototyping the game and all that. So we're working on sort of a 3D graphics art stuff, and I'm just trying to get some sort of nice unique graphics basically, and gonna go from there effectively. Yeah, all that from scratch. I've also got a custom C compiler, so we compile C, a subset of C, right, a limited version of C, into SpearV for shaders. So we share data structures and functions across CPU and GPU. It's not always easy to share stuff between CPU and GPU with functions because you don't have pointers. So some of those get repeated, but when you share the complex structures between CPU and GPU, that's all fine for the most part as well. So yeah, It's all pretty cool. Nah, I'm not using a windowing library. Sure, the APIs are a bit old and whatever, but yeah, you can do it. We did it actually all from. Did I even copy anything over? I think I had an old piece of code that I was sort of looking at as and bringing over bits and pieces that made sense. But I think for the most part, I added a lot more stuff to it as well, especially with the raw input stuff and game controllers. I've never done that before. Yeah, I've got a VOD channel if you're interested in seeing any of that, past streams and that. Everything goes up on there. So I just put them up on here. So there's some past rendering stuff I'm doing with some balls. Bunch of balls. Here's the UI stuff. It looks really ugly, but yeah, it's not really themed proper. But it functionally works fine. Custom UI rendering. And back here is when I was doing some of the Vulkan, initial Vulkan stuff, and then setting up the UI. Oh yeah, the input. UDev, XKB, and then I did the Windows version as well. But yeah, kind of need to post more YouTube videos about kind of the updates on this project, but one day that'll start up again. So yeah, I think because I don't have the conversion code, I've got to do it like this. Like this is a signed integer, and I don't have little nice functions that convert between signed of vectors and floats in that. So yeah. Anyway, so if we just simply add that, that'll be it. There's the project to screen space function, and it's all pretty good. This should get in. This will get inlined by the compiler, and this will get reused, so we don't have to worry about it. And I'm passing in the inverse one here, and that's kind of like an optimized thing. Probably. Ugh. Yeah, I could really just go and just construct all of this anyway. Ugh. Yeah, I'm just not gonna bother. Right, so you got those important points or whatever. So I want to bring those into screen space. Let's check them out. Also having some programming. I let him program. Also background program. Oh, cool. Neat. Right. So what sort of projects are you working on there, chat? Do you working on your own game as well? Okay, so we're gonna use that screen project to screen space. Oh yeah. And then the inverse pixel sun plane. Did I do my vec2s right? Amazing. So I'm gonna grab all of those and get them all in there. So that'll be the point 1, 2, and the far one like so. There we go. So they're all points in screen space now. So what we can do is do this whole min thing. Min max type of thing. Yeah, I think I might need I think I need 4 mins and 4 maxes, which is not really the best. And it kind of falls into like 8 mins and 8 maxes of float. Because of the X unit 2 dimensions. Well, let's just do it. So min, min, min. Important near in screen space. Close, close. Wait, that one far. Screen space. Right, so that'd be 2 and then 1. Copy, paste. That'd be bottom left and top right. So I think, yeah, we did if statements. Yeah, the compiler might be able to optimize this a bit. But yeah, so voila, that should be it. So we should be able to display that now, and that should be a proper bounding box around the screen, so we should be able to see that. So we'll be seeing the green lines will be the screen space bounding box. Right, that's looking good. So that's in that dodgy, yeah, look at that. On point. So there's your, the yellow is the view space, and the green is the screen space. So as we go down, and that edge goes past the middle, it's it's now fine there. Now we go across the X, oh yeah, you go, and as that top goes from the middle, goes down, it uses the back piece now instead, yep. So if you go across, and seems to be handling that just fine. Then it uses the front pieces instead. Go into the middle, it uses the front pieces only. And then you go across. Look, no! one, I was so close. Damn it. Right, this one looks alright. Yeah. Why? What did I do? I can't believe that. I was just like, this. I happened to go like the clockwise, and it just was the one that was making me just be so confident in my work. Right, so now we get to use the drawing API even more, right? It's amazing, right? Because we did the sphere, or the circle one, right? So now we can literally just draw all of these points. Isn't that amazing? So we'll just draw them with like a radius of 1 or whatever, and we'll make them like red. So this is where this sort of debug drawing API is like amazing and on point. What is going on? Oh, radius. Oh, it's like a border. I've done like a border thing. I guess we'll just do 1 as well. Yeah, you can have like a bordered circle if you want. Right, I think there's like a depth thing as well. Hang on a minute. Right, let's make these have a... Oh, what we ran is the depth. I think if I make this depth of 0.1, maybe that's what I need to do. What is going on? Yeah, there's something wrong with the... Right, they're showing up now. Maybe they were there, they're only a 1 or 2 pixel big, and that was the problem. Let's make these 2 pixels and see if we can pick up on them. Yeah, they're still there. They're just bloody small. That's not the... wasn't the problem. Alright, so let's make them a bit bigger. Let's make them 6 pixels. Yeah, I don't know if I'm a fan of the border parameters. It just makes me add more... I don't know. Maybe it's useful. But yeah, they're there. So... Right. So they're the important corners. That's fine. Yeah, that back... These flip like that. That's fine. Those like that. That's fine. What is up with these ones? I think the... Oh, it's not noticing the sign. There's something up that sign on the X. Oh, wait. Oh. Can I draw a sign vector or something like that? Start... Oh, my days. What are we... What is that? Didn't I change that header file? Damn it. Position... Vec. Pause... Vec. Okay, so in screen space, I want to see... Yeah, so I think what we need in our shader globals is probably also some form of like... Right, screen dims, F, and half dims. I would like these to exist. Let's just add them in because it's just so convenient. These being in there. We can sort them out later when we add proper resolution. They don't have to be correct. The divisions have to be correct. It's just rough. It can be alright later. So this means when we do stuff like this vector, and also we did that sort of projector screen space as well. We did this sort of like blah, 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 blah. So we probably do like a more or less half. Wait, I've already got half dims. F. So that'll just go in there like that. Boom. So that would then mean when we draw this vector, we can just say graphics global. It's going to start from the center of the screen. Half dim F, right? And now we just put our vector in there. So I want to debug draw a vector which will be the half dim. No, the sign. Right, I want to do sign dot x multiplied by, I don't know, 16. Let's make it 16 pixels big. And then sign dot y 16 pixels. So I just want to see. Depth, I guess. Then thickness? Sure. Right, so the arrow is pointing up to the top right. That's correct. Bottom right, bottom left, top right. So that's clearly where the problem is. Why is the sign just so wrong? Where do we produce the sign? Oh my days, it's my ternary operators, wasn't it? Yes, my ternary operators are broken in this macro expansion for some reason. And I don't know why. It's a bug that I want to fix. Before I do my next release of HCC. So I want to... Yes, it's a bit weird. Okay. Wow. There we go. It works now. Hey. Cool. So we've got a bounding box now. So anyway, when we're far away from the camera, this bounding box is going to be like... Sure, it'll be off. But... It's alright. It will do. It will do. I'm not sure if there's much... There might be able to be some shrinking ratio that you could apply. It's like, how close am I to the edge of the screen? And you might be able to shrink. I don't know. Just do some number and be like, oh, I'll do. But yeah. Cool. Pretty dope. Rightio, so now I've fixed that bug. The next thing to do is figure out, let's render more levels of detail because this is LOD 0. Oh no, new problem. Oh, this is just the ray tracer when it... wait, what is it again? Because the screen box is still there. What's the issue again? Yeah, I don't know what that problem is. Because it's not even like you're like, oh wait, there's the near. There is a near value, isn't there, or something? I think. Maybe something like that's a problem. No. I don't know what it is then. But yeah, we can probably get rid of this code here. Sphere and screen bounds. Maybe. Don't think we do bounding boxes anymore. No, we do, but we can put that in a different place. We've got the debug drawing code now, so we don't have to have it exposed in with some weird shaders. Right, what's the next thing we want to do? So we should try and render the lower levels of detail now. So when we do that sort of prepare cluster, what this shader does is it's launched, if we take a look at the console output, it's launched however many times we have levels of detail. So what we're doing is we're culling at each LOD, seeing if, and then for all of the clusters that pass the culling, we then add those to the array to process for the next time the shader is called. And so you call each of these for each level of detail for every instance. But we haven't got the culling in yet. That's something we want to do in future. So yeah, we're only rendering at this one here, as you can tell. it's 1 ms, probably because of the debug stuff we're throwing out. But yeah, so what we can do is prepare. I think I just did this, but anyway. We do something where we say, hey, over a cluster 0, like, render this thing. Basically, add it to the clusters to render and don't tunnel down anymore. So I want to change this to say, hey, if you're at LOD 1, let's do that. But this if statement shouldn't actually exist. This is just to try and help us debug what's going on in this shader. What it should say is if you have any spheres here and the cluster is big enough to render, then render it. But that comes later. We want to just debug a couple of layers and just see how it reacts. So apparently I see nothing, and we're not seeing any. We're seeing one cluster. So it looks like one cluster, right? But what it probably is we're. Yeah, I don't know if we've got. I don't know how many of these we're rendering in the same place. So we take a look at the benching. This is the second time it runs, and it's a bit faster, so that's weird. If it's occluded return, that's not included though. Right, let's enable some printing at least, just to see if we actually reach in here. So apparently it's like, no. Is it adding it to the ring buffer? What can I do? So yeah, it's printing out this sort of like cluster 0, which is the root cluster, and it has 8 children, but it's clearly not. Well, it's supposed to have 8 children, but it's not. We're not seeing those pop up. So we're seeing that box, but we're not seeing the box for the children. So why is that? Let's take this on a journey, and we're going to see. Does it reach here? It doesn't reach them. Cluster children node start index. It's no. It's saying it's got no children. What is going on? So I guess we go into the sort of like copy. Where is it called? Make persistent. This is where we sort of build the initial tree. I swear I checked this and it was fine. So this does a similar sort of pattern where it launches this shader, one for each LOD, and copies them over. So wait a minute. Have I hard-coded this to only work for one node? Did I do that somewhere? Yeah, I think I might have done that in the CPU code, and I've just not changed it. No? No, okay, that works for the right amount, yep. What about the bear? Okay, that's fine as well. Oh, did I change it in the other building code? No, they all seem to be doing for the maximum amount of level of details. So, okay, so I guess we can do some of these debug prints. I guess let's just say cluster index 0, or say 0, right? LOD, whatever, copy child to that. Okay, that's kind of what we want to see, I think. Right. Clearly too much stuff is going on. So let's just like say, okay, we only want to see this if cluster index 0 is the one. So I can see like all the children that get added. Wait, why is it copying it like a million times? What is going on? Let me think, what is going on? So you got 8 threads, it's not really the best sort of way you should dispatch. Are you really pulling out cluster index 0 every time here? Uh... Hmm. So I'm curious now, like, why this is triggering so much. This is very strange. So what I want to read, is probably this offset here into the ring buffer that's loading it from. And I probably just want to say if it is the first LOD. Right, so clearly as we insert into this ring buffer, we're inserting index 0 into there for some reason. That is not good. So I'm gonna... I don't know how this happened. I could have swore that we've debugged this shader before and it did not do any of this. Maybe I just didn't pick up on this. This is strange. Hey Psycode, how you doing? So long and descriptive. I only know how to read IJK, PQ. Yeah. How's it going? Yeah, I don't know. I like being able to come back to some code and sort of just read the code and see what's going on. A little bit. Yeah, wide code for the win. But I do see the point for short variable names when there is a repeating pattern across a wide area of code. I do see the point of that. I see a mixture of both. That's not how the industry works. You write code just once and it instantly becomes unreadable and you have to come back to it to some degree. To some degree. But yeah, there's definitely like, you have to understand the context of code to really read it. Very true. Holy moly. Cluster index. Yeah, so I want to see, like, if you insert... Yeah, so I'm only launching the first one now. The first LOD. I just want to read... Like... Ooh, source cluster child index. Yeah, like, what are we throwing in there, you know? And I guess we can do a couple of things. Right. Insert. Right. Insert ring buffer. Cluster. Blah, blah, blah at. So inserting this cluster index into the ring buffer at insert index. Holy moly, what is going on? So I might do... Yeah, that should be right. Right, it just seems alright, okay. Cluster 8 at 1. Okay. There's 8 reads. Okay. But you should only have one of these that come into here because that's all should be uninitialized memory, right? No. That's not good. Okay. So effectively what we do is we've got a cluster, we've got like an octree, right, of children. Where's our boy? Here we go. So we've got like a 256 cubed area of spheres. They're split into these 4x4x4 set of spheres, which means a cluster. There's a cluster tree where you've got a 2x2x2 set of children clusters. So this cluster is 2x2x2 set of children. So essentially a 2x2x2 set of spheres gets downsampled into a single sphere, right, in the lower level of detail, in that 4x4x4. So effectively, LOD0 has one cluster, just one. So it doesn't have any siblings. Yeah, I was thinking I could make it, we can make it so L1 is LOD0 instead, and you have 8 siblings. Yeah, so effectively, like, the other sort, we pre-allocate, like, still the children, all of the children clusters sit linear in memory. All of their sort of information sit linear in memory. So, but for LOD0, we've just pre-allocated 8 of them anyway. So the uninitialized ones which sit here, which are kind of bogus, they're being acted on in this shader here for some reason. So you could have one less level of detail. Nah, I like L0 being the way it is. So why oh why when we instantiate this thing? No. Oh, right, okay. If group index is greater than clusters to process count. Why is clusters to process count larger than 1? Oh shoot, it's not group index. No, no, it is. Oh, right, that is right. Yeah, so you've got 8 threads which come here and output the same piece of data. Okay, and then you've got 1 thread per child within that cluster, and there's 8 of them. Okay, now I'm reading the code right. So that's fine then. Actually, that's all okay. Yeah, for the win. 120, it's alright. Yeah, I could make some of the things shorter, but alright. Uh, mm, so is this a problem? What's going on? I don't think it is. So we're inserting those into the ring buffer. So the thing I'm looking at is probably fine. Let's look at the next level of detail then. Let's just enable that. Read that information. Then I just want to make sure that this. See, I think this start index is not being set up properly for the children, because that's why I was reading and was. Wait, how are we seeing them show up properly now? Like all the children again. We're not seeing them show up properly. There's one here you're seeing, and then you're seeing the ones over there. Interesting. Right, so you're inserting then 10 at 3. Right, they all get inserted into some. 11, 12. Where's me at 13? 13, 14, 15. Yeah. Okay. Okay. That's okay. Right, so let me add like. Let's go up to like 4 levels of detail. Okay, these sort of child boxes have shown up. They're still wrong. They're still in the wrong place, but they've actually shown up now. So let's go back to data LOD count and dispatch that copy, make persistent. Oh, and I don't see them anywhere. It's also probably is it making the stream lag? Oh, right. So, what is that? 7? Right, let's do 6. Six is fine. Copying the 7th one, and that one is I don't know. Where's this print code? Yeah, that's alright. Right, now they're blinking like crazy. So there's some kind of like overwriting going on. Did we couldn't have filled up something, right? You instantiate that like 2 or something, right? Okay, so you bump it. So you bump. How big is this buffer? It's called volume. Hmm. back at least. Volume, clusters, cluster nodes, buffer. I think this is it, yeah. Right, cluster cap. Max number of nodes. Oh my days. Right, max number of nodes. Times max number of volumes. Right, I wonder if this number is just too small. Can I multiply that by, like, I don't know, to like 8? No, it's not showing them. Still. So I don't know if it's that the size of the buffer they're going into is too small, or for some reason they get overwritten. Destination. See, it ends up setting. Where's that set? Children clusters start index. Where's that set? Right, it's probably why then. So, if the node has children. Oh, we set it here, right? What is that? Destination start index plus that. Right, then this gets stored back in here and then read back out here later on. So we store it in the source nodes. We store an integer in the source nodes to read back later from the parent. And then we reuse that, and I think are we offsetting? Yeah, we're offsetting it here. That's dangerous. That's why it doesn't work. So it patches the wrong one. Expecting to see something work then. Right, let's read over that again. So effectively what we store in. So node lock is the location. It's got an XYZ in cluster space of at that LOD, and it's got an LOD in there as well, so you know what level of detail you're at. So you can transition that into whatever space you want. But when we've copied it from the source construction nodes into a destination place, we overwrite it in the source cluster nodes with a sort of destination cluster index to know where this node was written to in the destination slots. So the first one happens in here when you set it up, and that one just puts it in as 0. Probably not right. We should probably call it alloc start like that. It's just 0, but that's more correct. So then you pull it out here, and whenever you go to destination, you're updating this here. Destination children node start index. Destination tree node start index plus. Right. See, these are kind of like relative indices sometimes, and it's a bit confusing what's going on. Why would you store an absolute index in here? It should all be relative from, because we're going to have some sort of defragging that has to happen, I think. Is that right? Is that correct? I guess, yeah, the child nodes are... No, the child nodes just allocate from the... Oh. I just want 8 in a row. Yeah, no, I could save doing a defragger if I just have a different allocation strategy. Like I do in the construction phase. Yeah, where's the because in the construction phase, don't I have a buffer that where's the free indices? Yeah, what's this thing? Did I not switch over to using this in the end? So we set it up and never use it. Okay. There's a bit of So I think... So I never switched over to using this thing, and maybe this is why the bug is happening. So I think what we want to do is... So essentially what we need is... We haven't actually got a cluster ref now. Did I act on volume instance index and then like a relative cluster index? And I was thinking I can... No. We probably just want a cluster index into... So rather than each cluster storing the volume... No, it's an instance. Okay, then the cluster, okay. Right. I think we can do this. So what we'll need to do then... So we need to get that allocator. Yeah, I don't want to bump allocate. Because then we don't have to do a custom allocator anymore. It just heavily simplifies the code. Well, there is a custom allocator. It's just pulling off a free index and popping them back on. And you just have 8 of them. Oh, shoot. So that would then mean there's no allocated start index. What is this? You kind of want to know where the root node is. So the problem then becomes if you want to free. If you have a volume and you want to get rid of it, you've then got to go down the whole tree and free it all. But I guess that's just a bunch of compute shaders that run after one another. That's the only downside with this approach. But I don't know if we'll have... Anyway, that's a problem to solve in the future. And it should be alright. So then this would then mean you would rename this to like... cluster root nodes. Root node index or something like that. Yeah, maybe that's the way to do it. Root cluster index. Do we need a number of nodes? Do we need the number of nodes to be counted? Probably not. Okay. So BVH tree, root node index. That's something we're gonna do in the future still. I guess we'll call it cluster tree root node index. Alright, so let's try and switch over to this then. So you would bump allocate 8. So in the make persistent setup, what we'll need is that free indices thing. Yeah. So make persistent setup. Yeah. So I need like probably a read. You're allocating, so read only. I think the variable should be in the I've not used this anymore, but I had it in some old code. I've used it for the spheres, but I never transitioned it over to the nodes successfully. Okay, so the way it will work is you simply just pull. Damn it! I can't believe the code is gone now. So inside the globals, I've got a an integer. This is just inside of another buffer somewhere, but we have access to any shader. Has access to this globals thing. There should be a cluster nodes free indices stack count. Yeah. Okay, so what you want to do is essentially probably get your free, it's not really a free index, but your cursor index, I guess, where you're reading from this. And the way you get it is you've got to do like an atomic sub of this thing by 1. You'll get back a cursor index in which you should be able to read this out. Now, nothing else should be running at this point in time, which is going to give anything back into this buffer, right? That happens when we free volumes, but we won't be freeing any volumes while the shader is running. So this will be safe to do as a separate operation. So we'll pull out our free index. This will then be our sort of like cluster tree root node index. And we're only just going to allocate. So this is actually going to have batches of 8. Right, you're actually going to have 8 nodes next to each other. But we're just going to waste 7 of them in this case. So this is our custom allocator. No longer do we have this problem anymore. And away we go. I don't know if we want to keep the count around, but we're just going to avoid it. And we just update this like so. Grid dims. Right, store it was copied to. Yeah. Okay, that's really nice. So now when we go down into our make persistent, and we have this sort of like, we don't do anything with this root node anymore. But what we do is we get so we're copying from the temporary construction space where there's just been bump allocated. And we're taking those and allocating children now. So You pick up the node, so this would be that root node, the initial root node, essentially. You've got the destination place of where it was stored. Now the first thread, because there's 8 threads here that work together, it's really not utilizing the Wave 32 capabilities, but it's the best I could come up with for now. So you're on 0. Yeah, so you're the first thread, right? This is how it was allocating before, was bump allocating. We had a pre-allocated range, and there'll be fragmentation from this, but now there's gonna be no fragmentation. So that's gonna be really good. So it's less work basically. So now we're gonna bump allocate. We get a free index, and this would be our destination children start index. Like so. What is this thing? That needs to go away. That doesn't exist anymore. Then we store it in here. And then we do a read lane from lane 0, because that was the one that got access to it. Child plus that. Yes. Cluster start index. No. Oh yeah. Children start index. That's correct. It's from the source node. Okay. I don't know if there's anything else that could be a problem. No, there's no addition that's going on. Alright, so I think we've got that sussed now. Let's try it out. Bear in mind, this gets run every frame. Let's run every frame. So because it gets run every frame, what I probably want to do is regenerate all the free indices again. So actually, this, if not, has not built. Volume cluster reset. Yeah, so to do only call this once at init time. That needs to be the case. Rightio. In we go. What is that? Oh, what? Destination children, whatever, start index. Yeah, what's the problem with it? Oh, right. Okay, I didn't put the free indices in the okay, I've got to do this in the make persistent place. Definitely read only. But I've got to populate this CP side. So make persistent. Setup, you get 1. And make persistent, you get 1. But we also need to make sure that we do read only in here. Cool. Oh my days, what's going on now? Right, so now prepare, okay, so now these cluster references, these used to work off relative indices from, and I was thinking I could probably pack these down, but no. It's not possible to pack, there's just too many clusters. So there's a cluster ref, this is basically linking so I should probably call this an instanced cluster, rather than a cluster ref, because volume cluster instance, where you're saying this cluster and this volume instance needs to be rendered. And that right there is the way to go. So let's go ahead and make that change. Cluster instance. So this is like a relative whatever index. Yeah, I think that's okay. Yeah, that's fine still. Oh, there's, what is this? Ray tracer tile bin instance. Cluster index. There's no plus start index anymore, you just fish it out with that. Right, there's another one that wants to do a similar sort of thing, I think. This is in the prepare clusters at level of detail. Cluster instance. Cluster ref instance. Yeah, it's no longer this sort of plus that. So this could have been what some of the problems are. We've just grabbed some zeroed memory. And so maybe the make persistent was actually fine. So that's something to look into. All right. Cluster instance. Yeah. Yes. Right, let's try that. All right, cluster ref instance. Cool. Some more cluster refs, these cluster refs. You've got a cluster ref? Everybody's got a cluster ref. There we go. Alright. Right, this relative cluster index is no longer relative. Oh, root node AKs. So prepare clusters setup. So this would mean I need to get the volume dot cluster tree root node index. Rightio, so we've just changed stuff now. So it means the computer could blow up and the AMD driver could be responsible. So if the stream dies, I'll be right back. Alright, we're still here. Things are blinking into existence. We still... this is just crazy. Yeah. Things. Right. So... sometimes... make persistent... Right, so I want to look at that free indices sort of like... this resets everything. It sets back to there and populates the whole buffer with free indices, and that they're aligned to 8 because there's 8 children. Yeah, that gets run every frame. Here, free. Okay, before we do any of the volume construction, well, we reconstruct every frame because I just want to. I don't know why. Yeah, because sometimes I'm debugging it, I want to print some of the stuff out, that's why. So, okay, what do I want to debug next? Let's run some of that make persistent stuff again, and let's see why some of the children appear and disappear. So make persistent, I don't want this to be ran once or twice, because I want to see the 2 levels of detail. Then in the make persistent set of shaders, what I want to see is probably, hey, this one copied to that one. Is that what I want to see? Yeah, I want to see that one. Right. So cluster index 0, then 2, and 1 in that lot. That is not correct. Oh, no. Is it? A little bit confused why that's like that. So you got LED 1. Where's LED 0? Right. Destination index. Right, it's copying the 8 children across. And they've probably got uninitialized memory. Wait. Copy child. Hmm. Cluster index is here, and that comes from in there. Right, let's run it once. See what it thinks. Let's just see what the first line is. Right. Cluster index 0, LOD 0, copy child 0 at LOD 1. Right, okay, I see what I'm reading now. Why is it copying all of those children? Those shouldn't exist. Wait. No, sorry. No. They do. Because these are the children of cluster 0. Yep. So, now when I do the next level of detail, for some reason, what is it inserting onto the ring buffer? So what it inserts onto the ring buffer is the following: insert cluster 8 at ring buffer position 1. That seems alright. So what I should be pulling out here so let's up that to 2 levels of detail. Why am I not seeing? So why is my destination then? Right, you know what it is? I think the custom allocator is returning me like, it's not returning me rounded. I've got to multiply it by 8 myself. No, it can't be that, can it? Is it really that? So this we should only be once per node. We're seeing a bunch of zeros again. Hmm. Let's see what index we're reading at. Right, from this end piece of the buffer, so they're all different indices, but they just read back something a little wrong. Okay. Why? Read only, read only. So what's the problem? Cluster nodes capacity. Is this even populate with anything yet? Right, we didn't fill it up on the GPU, that's why it says 0. This is our global inside our CPU. But there's actually a GPU version. Right here. Globals. So on our globals buffer, we simply just didn't populate this guy. And that's probably the reason why. Alright. Hopefully the computer still is fine. Yeah. Alright, we're still good. So now these numbers are, okay, still not making any sense. That's huge now. Why is that reading from the end of the... I'm sorry, what is this value? Wait, where is it showing up? GGFX. Should be popping up. Oh yeah, it's only showing up once, isn't it? Or it says that number there. So it gets thrown into the GPU. Okay, I didn't put it. Yeah, so it gets thrown into the GPU. Right, we're using that here. Because in that divided by 8, that's what that one should be. So it's not that big old number that we saw show up. From this, that's a big number. So you're saying... So I'm going to say like this equals... No. I think I want to say like this divided by cluster children count equal that. And I want to just display that out. It should be happening once per frame. Right, we didn't see that pop up, did we? If index is greater than or equal to that divided by 8. I kind of want to see this regardless. Let's move it here. We're not seeing it show up at all. Is this thing even being launched? Cluster reset. Number of groups. Let's put a breakpoint in there and see what's up. Call breakpoint. Right, looks like a number to me. Yeah, got numbers, you know. So rewrite as well. That's right. Oh my days. Is that going to be 0? Maybe. Yeah, 0 in it. Num groups. Yeah, 0 on the Y. Let's not launch him. What do I mean by that? I mean probably like a div roundup. Yeah, because I can't launch a group that's bigger, so I have to do it across 2 dimensions sometimes. It's still a big buffer. I think that was right. Okay, so launch that now. How's it look? Alright, I see numbers. So it's doing that big print now. Happening way too much. So it's not really displaying anything on GPU. Right, stream's still held up there, okay. Yeah, so I had this print that just happened way too much. Right, so now what we should be seeing is stuff being allocated with proper indices. No. So we're still taking them from from different places, but we're not getting we're not getting an index from them. So we can debug this, I think. So Y time groups width, that'd be 65,000 or whatever. Wait, is that right? Yeah, I think I need to debug this again. Right, debugger for the win. Right, I could have sworn I did this for the spheres, but I guess because I convert this from spheres to clusters. But yeah, I don't know what happened. Right, that so is a number groups width. Yeah, of course it is. Right. So if that Y ever goes more, yeah, times by 32, because there's 32 threads per No, that just sort of... So you're still, that's going to be 0 times 32, right? Hmm. Wait, is that right? So you got a bunch of like rows essentially. And on one row, you got the number of groups that you're launching times 32 times the number of rows. Yep, that's right. That gets your index. Now, okay. This be the number of nodes. So what does each thread get? Each thread gets a... So you want to allocate the indices with they're aligned to 8 each. But you want to sort of make them backwards. So 0 is like at the end of the buffer, so you pull out 0 first. So when we're doing debugging like we're doing now, the numbers just look nicer. So you got that sort of number of nodes. Take away index that you're writing into. Now that is kind of going to be divided. Yeah, so it's index times by 8. Yeah. Because that's the number of total nodes that you have in the buff. Can have in the buff. You can have, I guess. So it gives you... That gives you a multiple of 8 index. This will be round up to 8, I think. It must be. We'll look at that. What is that number? So it is a multiple of 8. Good to know. So we kind of want to debug like the end of the buffer, don't we? So let's just say like, well, what is like the end of the buffer is that take 1. So whenever your sort of index is equal to that, can we print out what is in that buffer? Or what is in that slot into the buffer? And slot. Let's take a look at that one. Oh, wait. Why run it in there? Just want to see the, ooh. Right, I hit the breakpoint. Get rid of the breakpoint. I'm looking for the printing of end slot. 0. 0 is at the end of the buffer. What about what is second second end slot, I guess. So take away an extra 1. What is second end of slot? Damn it. Right. 0. That's not what we wanted. Right, this number clearly needs to be like 8 or something, right? So why is that 0? And also, why didn't it underflow or, you know, it's a bit weird. So the maths behind it, and we can just see this maths now. Does this... so we can probably write this out. So that will go here, and then we'll fill in the variables. So it'll be that number, take that number, basically. What am I trying to achieve? How large scope are we talking? I'm just trying to get my cluster LOD system up and running. So I'm just trying to... Currently, we're a bit in the weeds where we are... When we're constructing these clusters of 4x4x4, these guys, right? In like a volume constructor, I'm basically working on the allocation system of these nodes. The free list array is just not populated correctly. But after this, it should help make it so we can render these levels of details of spheres, which are 4x4x4 set of spheres. Yeah, currently the way they're getting allocated is not correct, so it's leading to bugs. I'm just debugging that right now, basically. Right, let's print that out and see what's going on. Cluster children. Right, so it's this number. Let's punch into the calculator. 3, 1, 4, 5, 7, 2, 8. Take 3, 1, 4, 5, 1, 2. 16, take 8. That's the number I'm looking for, 8. So why am I reading it out wrong? What is... Oh wait, it just said 8, didn't it? No, I did that, take that, and it gave me 8. No, 16. Yeah, 16. Yeah, 16 difference, then take 8. Yeah, that's right. What the crap? So why? Let's punch that in again. Second end slot 0. Why? If index is second from last, Um, what am I doing? Is this read only or something? What is going on? 3 indices in it. Write only buffer U32. Is it not synced correctly? What is going on? Oh, it's right. It's marked as write only, and I'm reading from it. That's why. Debug it. Okay. Right. Let's make it read write for a moment. Right. So that's, yeah. I need to make that in my compiler so it does give me an error. That's on my to-do list. For write only resources. I've done it for read only. But yeah, this wasn't the problem. This is just like our debugging here was not showing up correctly. So the number here. Oh no, it's still buggered up. Yeah, okay, so this is the end slot because it's take 1. That's fine, it should be 0. Let's do -2 then, second end slot. There's a 16 difference, and it's still showing up 0. Why? Hey, Paya. How's it going? Oh, thank you so much for the sub. How you been? How you been? Do you ever fill them up? Like, what happens if I just read the one that's at 0? Now, what does that one do? Does that give me anything that's... Yeah, I get a number. Are we getting multiple writes to the same place? No, because we would see it, right? We would see multiple. How many back do we need to go until we reach something which is a non-zero value? Right, that's still 0. For some reason. Let's go back like, I don't know, 256. Still got a slot of 0 apparently. Right, this is a problem. Volume cluster nodes capacity divided by 64. That was the number of nodes in a sphere. Sorry, spheres in a node. But I copied this from that. So I think that's the problem when the buffer is just not big enough. And so obviously we're looking at the end of the buffer. And that's why. So if I put that back to 1 or 2 again, we should see 8. Right, okay, we fixed it. Good. So there's 8 there now, which now means the nodes should be getting allocated properly. Ugh. Man. See, that could have been a GPU crash as well if I wasn't careful, because we just indexed that side of a buffer. And that would have not been good, because it was just brought down the stream, because AMD. But now we know it's allocating fine. So we go to sort of make persistent. What we'll find... Okay, it's good. What we'll find based on this print statement is that we should have some allocation of some... Right, so... Oh! Wait a minute. This This looks like a lower level of detail cluster being rendered. Sorry, higher. And this is like the volume that it sits in. So maybe that's right. Maybe things are starting to happen. Right, okay, so we've allocated, yeah, they're all at different places now, right? So you've got the root one allocates its one here, starts at 0. All of its children start, wait, no, yeah. The root one starts at 0, and it's got a bunch of siblings that are invalid. Because there's eight siblings that get allocated together, and the root, there's only one cluster at LOD 0, like that there. But from then on out, all the children of a cluster have 8 siblings, contiguous in memory. So what we find is there's 8 children on LOD 0. Here they are, right? 4 plus 4. 8, 16, 24, 32, and so on, right? Good. So they're all like, they're all kind of next to each other in memory. So I think what we're starting to see then is they're being allocated properly now. Copy to... Right, let's read this right. So they copied the child. Destination. What? Right, so that's overwriting the root node. That's not good. That's literally overwriting the root node. Why did it do that? Crap. Right. Yeah, so the first LOD is overwriting itself. Right, LOD 0 is overwriting itself with LOD 1 nodes, I think. Yeah, so see here, it reads out 0 for the root node and its siblings. Then this one here, from the one that's just before it, reads out 0. Yeah, so I think I got like an off by 1 error again. Okay, so that's the reason why we're only seeing one node show up, because we're seeing one of the children getting copied over the root node or something like this, and then that one just gets displayed. So the allocator is still a bit buggered. Not to worry. Free indices. So I guess I don't have to take 8 then. I'm still a bit confused by that. Let's bring this back. Let's do a take 1. Oh, it's a divide round up, isn't it? I don't know, actually. Right, it reads a 0 from the last slot. Second last slot. No, count. Oh, I didn't do a takeaway 1, damn it. This code's all fine. This code's all fine. Well, the problem is it's very simple. I've done an atomic subtract. So what does it do? It gives you back the previous value that was stored in here before the subtraction, but not after the subtraction. So what I'm getting back is the stack count, right? Or the stack capacity the first time it's called, right? But what I need to do is do the subtraction here locally, and that is the problem. Alright. So that worked fine. 100%. And now we'll see LOD 0. Wait, sorry, now we'll see LOD 1. Oh, come on. So at least they are consistently showing up now. Let's just double check it. Hey, Crimson Mania. How are we doing? Right, so great. Now the first LOD 0 allocates its children starting from 8. Yep. Alright, that is good. So now they're not overwriting each other at least. They get copied to 8, 9, 10 or whatever. Yeah. And these guys get copied like that. Nice. So now it's just a case of what is it a case of? When we do the prepare clusters for render, where we sort of go over, we start the root tree and we root the tree. We've got this sort of debug ABBs and OBBs being drawn. And then okay, so we're only going to go ahead and render LODs, LOD1. So what we should be seeing is the bounding box for LOD0, which is this one. And then all the smaller ones are LOD1s. Why is LOD... We should be seeing... These spheres should be actually half the size, and we should be seeing double the amount. We should be seeing an 8 by 8 by 8 here. So one, the clusters are all in the wrong place. And two, the sphere sizing is just all wrong. So I think if I line it up right, these clusters probably are next to each other. Can you see how we're sort of like kind of lining them up a bit? So I think they've just been separated a bit too much. I don't know why this one's like a bit offset here like that. Yeah, there's something a little bit... Maybe they're aligned. But yeah, something's with them. Good, thanks. Just chilling. Went to Rust Nation this week and now I'm exhausted. Is that a little... I don't know about that. How's it like? Convention? Conference? Rust programming language? It's in London. Represent. Fair play. Was it good? Did you have a good time? Was there a lot of blockchain there? Or has that all died out now in the Rust community? Okay, so I think then... Yeah, I wonder if this should be normal, unorm. Maybe that's the thing that's a bit messed. No, this has made them even smaller. Right, that one right. Right. Okay, interesting. It was good. Yeah, I had open bar. They had an open bar each night. Oh my days. Wow. Sounds like you must have got destroyed. Oh man. Drinking. So easy to go overboard. So why are they sort of like, wait, did I even like recompile that? Pew, 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 pew. Yeah, so what are we trying to see? What are we trying to see? So position in local space and position in view space ends up being messed. It's something to do with this LOD thing, I reckon. Yeah, it's something to do with, right. I think this might be a print task. Just got to get the right variable. So what I want to see is like, how big is my LOD dim? And is that correct? So what do I mean by cluster LOD dims? How big is a cluster? Actually, I don't even know. Let me just see what they say. 1, then 2, 2, 2. Right, yeah, so how many clusters in a level of detail across one dimension? So you got 2. Great. So what is this? How big is a cluster? Half a cluster in unorm space. So 0.5, because it's a unorm, right? So 0 to 1. You're going to fit. Oh, yeah, that's wrong, isn't it? Oh, yeah, so it's the half. Right. Yeah, so half of a cluster is obviously 0.5 in that space. Half of a cluster is 0.25 in LOD1 space. Yeah. That seems alright. What other things can we mess around with? So cluster position in cluster LOD space divided by 1 or divided by 2. Divided. What are we trying to work out? So in LOD1, this would be 0, 1 divided by 2. The 0, 1 then divided by 2. So you get like a half, basically. Then plus 0.25. As I pitched you about. Yeah, in unorm space, I pitched you about 0.25. That seems correct. In local space. Yeah, I think that seems alright. Then you convert it into snorm space. So minus 1 and 1. Good old snorm. Then things seem alright. But obviously we're rendering them. I'm using that. Right, I'm rendering it. So obviously it's wrong. So what is my position in cluster LOD space then? Because if this... Oh. Also spike there 2 even had a hackathon guiding a RC card by communicating Mostly helicopter as the car had no sensors. Oh. Wow. Pretty cool. Quite intense. So, was there a group of people trying to get that up and running there and people were watching them do it? Right, these numbers. 4. Oh my days. It's not the cluster position. That's the sphere that's the sphere position in cluster. Right. So I don't know why it's so okay. Right, so that's what I'm storing in there. So it's not really like the right. So what we should really be doing is I don't know. This is not necessarily the right way of doing it. You want to multiply it by... So since we're talking about spheres here, you probably want to multiply this by a number of spheres. Right. Um... Okay, so do I have something like cluster sphere? You know what? Cluster dim, I guess. Right. So I think that corrects it there. That'll give us... It's uniform space though, isn't it? That'd be right. So I think when we do the ray tracing as well, it's a little bit... This is in here as well, and I think we need to do a similar thing. Multiply by this cluster dim. I was thinking it would be a bit different, that position, but maybe... Cluster position... And then... Divide by cluster dim. Yeah. Tile, that's the tile binning code. Right. Do we do anywhere else? Okay, I think that's it. Let's try that out. Sweet, they're kind of all in there. But, one problem. That's not the right level of detail. Yeah, there's something real messed up with it still. Ooh, these spheres should just be smaller. I don't know what's going on. So let's only render one sphere. Sorry, one cluster. We need to make sure that we select the right one. So what I want to see is, can I get cluster index 1? Maybe. Or cluster index 8, maybe? Where are we at? Oh, So if cluster index is equal to 8, try that. Which one do you enjoy, my Xlog or Win32? Not very. They're both kind of terrible. Holy crap. Alright, stream's still live. Nearly died there. Yeah, we could participate for the event. There were some libraries we could use to make it easier. Oh. Thing. What shader's taken a gazillion? What? The 3D drawing is taking bloody... Okay. Clearly. Oh, so it keeps rendering all the time. Right, it went and drew the whole tree. No. So let's say if you're less than or equal to 8, we'll draw you, and it shouldn't draw the whole tree again. Okay. No. I don't want to render 0. Damn it. Yeah, so that just renders 0. Why don't we say if you are... Let's say if you're equal to 8 there, and we'll just say and a 0 on... Ooh. And only if you're equal to 0. Down here, so you can traverse down to the children nodes. So I'll stop it from rendering everything. Okay, so we should only be seeing... let me only debug draw for... Damn it, why is this debug drawing all in different places? What I want to see is all this information, but only for that one small node. Right. Okay, so what we're seeing is it's trying to render it far bigger than the actual box is. So why is that? Like, what's around this white box? White half cluster dim snorm. So it thinks, like, why? That's not right. You think when API is a lot nicer than Xorg? Probably. But they're both, yeah, both pretty bad. Yeah, both pretty archaic. Yeah, I think the Xorg one literally just doesn't make any sense. You've got to, like, know the protocol for it to sort of, like, make sense, I think. Alright, so why is that? Snorm value. We printed that one out, right? And we saw... Pretty sure. There's the print statement I want. Pretty sure... Oh, it wasn't that quite that one, but yeah. I think we saw the... What the Snorm value, but... Pretty sure we saw that was sensible. So that should be 0.125. Half dim snorm. Oh yeah, 1. Yeah. And then so that's obviously like half. Yeah. And then 0.5 in. Right, so let's render this one white. Let's render this if 0 as well. Okay, so I think that white. Oh my days, I know why it's wrong. No, I don't know why it's wrong. Scale the axes. Oh, they didn't pass in T into here. Ah, yeah, bugger. Why did I do that? Why didn't I just do this? It's not like it's coming in via a pointer. Let's do that for the CPU side as well. Oh my days. Right, so no wonder why that was looking a bit weird. Okay. So now... right, let's revert that back to this only working on cluster 0. So we can re-debug what is... yes, debug all stuff in cluster 0. I want to see if that debug thing is... Okay, so that white box clearly goes around here, okay? And then this view space box, yeah. So that's LOD 0. Now we're trying to see a smaller LOD 1, which is going down here. So these should break apart into smaller ones. So clearly we're not seeing that. This kind of the size is okay, probably. Did I mess up on the translation? World from local. I'm not applying a translation to... Right, when I'm debug viewing that box, I'm not applying my offset to that. Yeah, I'm not applying an offset. So if I take like view from local dot position, I guess it's called, isn't it? No. Translation. Yeah. Dot x plus equals, let's just try this out for a sec. I think that's the reason why the debugging thing is not showing up in the right place for the lower LOD. No. Is it takeaway or something? In local space. No. But the access line banner box seems to be okay-ish. Like it shows up like for one of the parts, if you will. So I think it's just the way that we're constructing the size of these spheres. So where's the sphere size? Right, so we pre-allocate, we're just going over all the tiles and say pre-allocate this. Right, so the tile, it's done in tile bin then. Tile bin, there's like a sphere dim somewhere surely. Sphere, radius and view space. Radius in local. Right, okay, sphere dim in local space. 2 divided by volume dim, so that's 256. Right, can I see this value? We should see this like 64 times it's been spammed out. And I don't know. So 0.5 in local space. That is. Wait, what does that mean by dim? How big it is? I don't. Is that radius? No, that's how big a sphere is. And we offset by half the dim, which is the radius, get into the middle of the sphere. Is it 0.5? No, because in sign norm space, that gets you... Right, it's the local space of this... In the cluster, that's not right, that's not right. What is cluster LOD here? It should be 1, right? 0. There's a problem. Why is the cluster 0? Like, what node are we referencing here? No. That one. Like, what are we... Did we push, like, 0 on? Damn it. I think I got hard-coded 0 somewhere. Oh, for crying out loud. So I think in the clusters to render, we push that on. Oh, no. Cluster... No. What are you doing? So why then is this a, why is it pulling out the wrong... Right, tile binning. Where do we... What's the order of these shaders? They definitely have it in the right order, right? Yeah, so you do prepare clusters, tile bin allocate tile bin. So we should be putting let's read that. So cluster index or render index, right? It pulls out 0. Sorry, it looks in index 0. And it pulls out something with 0. Great. Why? Let's go to that prepare again, because that is weird. Prepare clusters to render. Somewhere around here. Where did we put this in? Right, where do we chuck that in? That's 0. And we chucked in. Yeah, it's right there, right? If it's equal to 8, put it in. Weird. So, cluster, okay, what? Are we doing the right sort of accesses? So prepare clusters, pass it in there. Right. Did we sync? Oh. There's nothing else that... Damn it. We don't even set up the buffer in the tile binning code. It's not even copied in there. Like a null descriptor. My days. Crazy. So, how? I don't know how that works. So it was reading from a buffer successfully and not even crashing my GPU, which I swear I've seen it crash the GPU before. Alright, there we go. Yay, so there's a lower level of detail now. So if we let them all render, where do we do that? So I think if we bring back, right, let's let them render if they, so you only go into here if you are, yeah, let's just let them all go in here. Wait, no, if you're not 0. And away we go. Boom. Excellent. So this is LOD1. I want to fix up some of the debug drawing, I think. Because I think there's something to do with that sort of white box that leads me to think my view, my sort of OOBB debug drawing might not be working as I hoped it should. Yeah, so here's LOD0. Oh, 1. LOD0 is a 4x4x4. So, that's cool at least. We want to try and get a full 256 cubed rendering. And it should just work from here. If we just let it go. So, should we try that? Just let it go. Well, we don't. Let's take off the spheres count and just say, hey, to use the actual spheres that's in there now. Like we just said, hey, render all of them. But let's just see if it's gonna be a bit smarter now. Okay. Clearly got some invalid data happening, which is not good. That's not good. Bit count, or of those. That should be right. Okay. Yeah. All right. So I think next time we'll investigate further, because let's just admire that for today. So at least we've got the debug draw 2D working, and that's pretty nice. LOD 1 is also kind of working when we hard code the balls to 64. Yeah, maybe there's no spheres at LOD 1 for some reason. There should be. There should be some. But yeah, in the next stream, what we're going to do is obviously investigate why there's no spheres showing up. We're going to improve that sort of view. This OBB debugging thing seems to be a little bit off when we on LOD 1 for some reason. We'll investigate that. And we'll try and get LOD 2, 3, 4, and 5, and 6. Hopefully those should just all work, because after you've done the first 1 or 2 LODs, the rest should just work. So that's the plan. So hopefully we should be soon seeing a full set of spheres and seeing how crazy bad the performance is for that. And then yeah. So the next stream will be on Tuesday at 6:30 p.m. GMT +1 now, because time zones have changed. Let's rate some body. Is there any C or CPP or something along those lines? You know, I might just bail because I have to get going to bed really. Right, thank you for coming everyone. There are I have a Twitter where I post stuff. Now stuff going more visual, I think I'll post more. Discord as well, I'm gonna come hang out, chat, and talk about programming while we're not streaming. So yeah, have a good bank holiday, Easter Monday.